applications. Just give you a brief introduction of Professor Prashad. Professor Prashad is having a PhD from Indian Institute of Technology, Kanpur, then Master of Science and Technology in Applied Geology, then Indian School of Mines, Dhanbad again, and he has a Bachelor of Science Honors in Geology with Physics and Mathematics from 1998. He is DD College. DD is done to DD College, Keonjhar, Utkal University, Bhubaneswar. Now his present assignment is Assistant Professor, Department of Applied Geology, Indian Institute of Technology, ISM, Dhanbad. His areas of specialization are application of hyperspectral remote sensing in geosciences, coal and metal, and digital image processing, microphotographs, satellite imaging, automated, and geospatial analysis. This is a brief introduction of Professor Prashad, and I think he has already shared his presentation. So I'll be requesting him to take the floor and start his presentation. And gentlemen, I can see only 33 participants as of now. Of course, we should have 53. So 20 are yet to join, but we will not wait for anybody. As I made it very clear earlier, there are 2 or 3 things which I want to once again repeat to the participants for your personal consumption as well as for communicating to other friends of yours. That number one, there's no delay, even by 1 minute will be tolerated. Anybody comes late, more than 5 minutes, will not be allowed to join. Second thing is your 100% attendance is a must to get the MPDP certificate. And third is that you have to attend the anybody? You have to join the assessment in the end of the session and clear it. Then only you will get the MPDP certificate. I hope is it clear to all participants? Can anybody answer?
Yes, sir.
Okay.
Yes, sir, it's clear.
Yes, sir.
Yeah, I have also sent you a couple of mails and other messages yesterday in which I have clarified all these points, and I have shared the link also for today's presentation. Now, every day for every presentation in both the sessions, link will be different. That means for a day, there will be one link to join. And I'll request all the participants not to share the link with anybody, as this is a paid program and it is absolutely for your use. Okay. So please take care of that. Okay. So I leave it now to Professor Prashad and Dr. Saab. I request you to take the floor and start your presentation, please.
Thank you so much, sir. I'm really grateful to Deepak Vidyarthi, sir, for giving me this opportunity to talk to this young team of working professionals. I'm really grateful to the MEAI for this platform so that I can present a very unique topic that can potentially change the way you do mining or related associated activities. So the topic of the present talk is hyperspectral remote sensing and its applications. And I will talk about what is hyperspectral remote sensing, especially for those who may not have a background in remote sensing aspect. We'll talk about hyperspectral signatures, the platforms which are available for such kind of work, and what is the working range, and how do we achieve, say, the study of minerals and rocks and ores, and what are the sensors and equipments available to us. And then there are specific case scenarios where we have implemented the same in our labs. We have also applied for some patents related to such work. And obviously, not only it will help in mining, but it will also help you in, say, increasing your portfolio in terms of patent and other things. And then we'll also discuss some very useful case scenarios where, other than mining, you can also take care of environmental impact assessment, biodiversity assessment, acid mine drainage in real sense, and the impact on ecology and environment other than the mining part. So before we go into the details, the first thing one should know is that the primary energy that we receive on the earth is from sun, which is extremely useful for us. And as humans, we typically see in three wavelengths, that is red, green, and blue, that you know as a three primary colors. And obviously, you know that if somebody is red color blind or green or blue color blind, then their vision is different. So our eye has evolved in a way to see something in the range where the intensity of the solar radiation is highest. So you can see this curve. Its peak is there in this visible range that we call from blue to red range, or in terms of nanometer, 400 to 700 nanometer. And then before that, we have a UV range, and after red, we have the infrared range. And later on, we have a far infrared range. And obviously, you can see the other two peaks are coming here. This is a emission one. So the major peak that you see here is coming from the solar radiation, and the other two peaks that you see at the end of the spectrum is because of the emission. Every body has its own temperature, so they emit, and they emit at specific wavelength. And this is true for minerals as well. So all the objects on the earth during daytime, obviously the solar radiation is the dominant one, but still at the night when the sun is out, the emission spectrum can still be useful. And one of the notable features is that around 41% energy from sun is around the visible part. UV range, which is also useful for mineral exploration, is around 9%, and infrared is around 50%. But then you can see that in the mid and far infrared range, it basically flattens out. So at 20 or 30 micrometer, it is really flat. So signal to noise ratio in the mid and far infrared range is very low compared to the visible or near infrared. So this has to be considered because the signal to noise ratio makes a lot of difference in analysis and accuracy. So before we go into the details, let us see about human eye. Human eye we see in red, green, and blue. Blue is 440 nanometer, green is 545, and red is 580. So based on number of studies, this is the approximation.
Okay.
So I may be saying in 580, you might be saying in 581. So that is why my red is not same as your red, or what I see as a pink will be a different pink for you. So that is why we typically see in a specific range, say blue is 420 to 440. So and then green also, it has a range of 20 to 40 nanometer. So the point is, a person living in a tropical region or equatorial region may have a different vision compared to a person living in a polar region, because again the sunlight radiation intensity is different from equatorial to polar. So our vision actually varies. That is the point. And that is why you may have seen that blue-eyed persons are more in the polar regions compared to equatorial regions. So the same thing, red, green, and blue, if we record through instrumentation or through specific detectors or sensors, we can combine them in specific fashion to create a picture. And this actually happens in our eye in a natural way. We see in red, green, and blue, and our human brain basically process the data and presents us a picture. So we do the remote sensing, from your birth itself. But then in machine, you have the advantage that if it is 3-2-1, you can make it 1-2-3. So you can flip the combination, or you can switch the bands. So here you can see that if you switch the bands, the same feature starts to have a different color. And what is the advantage? The advantage is the same object now may be visible in some other colors, and they may be now be more distinguishable compared to previous efforts. So the detection in several bands and their post processing can help you see many more features which otherwise is not visible. Say the top picture is what we see as humans, that is why it is true color, but the same in different combinations or of bands, we see different colors. So this is a machine vision and other one is a natural vision. So machine vision can produce varieties, and that can help you detect specific objects. So this is again another thing. You may have gone through this color blindness test before you may have taken your job as a mining engineer or others. So you can see that if you are perfect normal vision, your red, green, and blue detector in your eye is perfect, then you can see the numbers in those circles. But those who are having 1 or 2 color blind, they may not see these numbers. So again, the point is a detector, if something is there on the ground, but if you do not have the detector for this, or you do not have the sensor for this, then you cannot really see that. That happens with minerals as well. You can see, say, something like a chromite or chromium, but then within that chromite, you have other impurities, say, or maybe that can come out as a co-product or byproduct. One example is, suppose vanadium is possibly present in 700 ppm to 7000 ppm. So your main ore is chromium, but within that chromite that is giving you chromium, you also have vanadium. So those things are not visible to you. So how you can find out those invisible things? And in hyperspectral remote sensing, we have seen that even something which are as low as 1 ppm is detectable, because machine vision is different from a human vision. So let us see another example. So this is a normal color. You can see the red, green, and blue. And in the other case, it is different. But then our human, say, intelligence also comes in, because you know that the top will always be a red and green is always at the bottom in a red, yellow, and say green traffic lights. So it is not only the color, but also the context is also important. So which part of the spectrum or the sun radiation spectrum is useful for us? So this is the visible spectrum from 400 to 700 nanometer. And this is, let me take the pen. So this is our normal human vision. But then at the same time, we have a UV at one end and near infrared NIR, short wave infrared SWIR, medium wave infrared MWIR, and long wave infrared as LWIR. Now this LWIR here, it is shown as 15,000 nanometer. It can go up to 30,000 nanometer or 30 micron that we have seen earlier. Now this is another chart where you can see that this is the radiation at the top of the atmosphere, and this is the radiation, the red one is near the surface. So this difference shows you that a lot of absorption features are there. So a lot of radiation is being absorbed by the atmosphere. So it is not only the features on land or minerals or vegetation on land, but also the atmospheric gases absorb in specific ways. And these are again have unique signatures. So you can always find the amount of carbon or carbon as CO, carbon as CO2, or carbon as say CH4, or the ozone, and so on. So not only say our mining domain or geology domain, it is also useful for say people working in the atmospheric science. So the same principle works in different ways. So this is again important for you to understand the different evolution of the remote sensing as such. Earlier, all this Landsat and Aster that you have seen, they are typically called as multispectral, because the bandwidth is like 20 to 40 nanometer. So each band, say red, green, and blue here you see, the width of the channel is like a width of your window. If you have say 3 windows, they have red, green, and blue, and they are very wide. But the moment you break down this window into very specific components, small ones, like every 1 nanometer, or if you have some satellite ones, they will be 2 to 5 or 10 nanometer. So instead of 20 to 40 nanometer. So there is an obvious advantage that these 3 bands have now become say around say 30 bands, or this entire range from 400 nanometer to 2500 nanometer has become 300 bands. So what is the use of it? It is the same as if, say, if you are one color blind, you cannot see some features. In the same way, if you can break down the same band into multiple bands, you can see many more features. So multispectral use, so these are all related to the width of the band. So these are known as wideband remote sensing, and hyperspectral, we call it typically a narrow band remote sensing, because the bands are narrower in the size. And this gives, and we'll see how this is useful. So multispectral, suppose all the multispectral satellites, they have 5 bands, 7 bands, 10 bands, 11 bands, but within the same range, now we have hyperspectral imaging satellites or the ground lab-based equipments, which may have 200 to 300 bands. And that is where the magic happens, that you can really discriminate not only suppose iron, but also the different types of or the different minerals of iron. You cannot only separate clay, but you can separate different types of clay. And this is highly useful. So this is another example that this is the spectral response of a leaf, and this is what it shows in different channels. Earlier, we used to have one band in say red band and near infrared band. So if you want to know the vegetation in an area, two bands are only useful. The red band and near infrared band. And the ratio of these two can give us vegetation is present or not. But now when you have so many bands, you cannot only tell about the vegetation, presence or absent, you can also tell which type of vegetation is there, which type of tree is there, which type of shrub is there, which type of crop is there, and so on. This is a case example where you can see two minerals, calcite and dolomite, which have very similar chemical composition, and the signatures are very similar, but the noticeable difference is that in this particular one, you can see the peak of the absorption band is different. It's slightly shifted from in calcite and dolomite. So that is why when you have these narrow bands, you can differentiate between calcite and dolomite. But if you have a broad band, you cannot really differentiate between calcite and dolomite or tremolite. But in a narrow band, say data collection, you can always separate the calcite from the dolomite. In the same way, some other minerals have been shown. You can see chlorite, gypsum, or the clay kaolinite. They all have very distinguishing features. So obviously, in a typical remote sensing, we look for absorption features where you can see the you don't have much reflectance. It is absorbed, that particular wavelength is absorbed by the mineral, and non-absorbing bands where there is no interaction within the mineral. So you can have a non-absorbing and absorbing band, and ratio of this can give you, so basically, so this depth that you see, and this depth is at one location, this depth is at also at second location, this depth is at third location, and this depth is at fourth location. So a simple arithmetic algorithm that targets these 4 or 5 absorption bands having differential absorption capacity can help you distinguish gypsum from illite, dolomite, calcite, chlorite, or kaolinite. So you can see that very simple diagnostic features can help you distinguish minerals. Now, in what scale it is possible? It is possible under a microscope. Now, you may have seen a lot of, say, microscope, like how to distinguish pyrite or calcite or quartz or feldspar under a microscope. But at the same time, if you do it through these signatures, it is even more accurate. And it can also be automated. So a lot of AI and machine learning algorithms are being used nowadays to train and to find out the specific minerals under a microscope. Or the same thing can be done in a hand spacing. In a megascopic sample, if you want to know what type of minerals are there, you can always scan with a camera that has multiple bands, and then if it has a customized algorithm, it will tell you what is the amount of specific mineral is there. The same is also, so these are like lab scale, microscopic or megascopic, but the same thing is also being done through satellites or platforms in the air where you have UAVs, the unmanned air vehicles, or aircrafts. You may have a helicopter or maybe a high altitude flying aircrafts, or say 10-kilometer aircraft flying aircrafts, or maybe 700, 800 flying height satellites. But obviously one of the disadvantages with satellites is that it is far away from the object. So the signal to noise ratio is really low. But then when it is a microscopic or megascopic situation, the resolution is high and the signal to noise ratio is also high. So that is why nowadays aerial hyperspectral remote sensing is more popular because it gives you 1 or 2 centimeter pixel size and it is much more closer. So UAVs are like 30 meters from the ground compared to a 300 or 800 kilometer in satellite. So that is why the accuracies are getting much more better in UAVs. And the other picture that you see is suppose a borehole core. in a borehole core, a experienced person can tell you the calcite or chlorite or illite or gypsum and kaolinite, but a machine can easily distinguish all the features if you train your algorithm to detect these minerals and find out the features within the image. So after classification, you can see that individual mineral distribution is visible, and then you can carry out all the statistics like mean and say total volume and so on. So that makes it to a different level at a much say smaller limited time. So nowadays in hyperspectral remote sensing, this has been there for 10 to 20 years, and now a whole array of equipments are available in India and abroad. And you can see that it does have say a laboratory setup. It has a tripod setup for carrying out in the field. You can also purchase in a drone setup where the hyperspectral cameras can really capture the signature of a larger area at 30 or 60 meter height. And then you have also aerial setup, like NASA has the AVIRS sensor fly on these planes, and they have done the mapping for say very big regions. And one of the example is Afghanistan have been totally mapped with this kind of equipment. And for other regions of the world, they do have satellite, because from a satellite platform 300 or 800 kilometer above the surface, they have also mapped out the Earth for different locations. Now a handheld camera is also coming in at much say reduced price, though the resolution and accuracy is limited compared to a laboratory setup of field or tripod. And people are trying to miniaturize this in a cell phone. So obviously from 2001 onwards, we have seen a revolution that earlier people used to buy DSLRs, a very high resolution cameras to take pictures. But now hardly anyone goes after DSLR because you already have 200 megapixel cell phone camera available to you. And that can take really as good pictures as a DSLR. But then the same cell phone in future may carry more than 3 bands. So now this carry only like red, green and blue, the 3 bands, like our human eye. But in future, companies like Apple and others are working to add infrared bands or add a UV band so that it will be helpful in a number of ways. So this will, and it may take 5 years or 10 years, but then down the line, when the price comes down, this is likely to be a very big hit because it will be really helpful for say anyone. And nowadays for mining, these companies have come up with a small equipment like a portable gun where you can point it out towards a specific mineral or ore or rock, and it can tell you the composition. But they are selling it as a customized one. Means if you are working in a chromite mines, they may sell this equipment for you for chromite, and it may not work in a iron mine. So these are highly customized for specific minerals or only a small set of minerals. But if you really want to use the equipment in a multiple environments or manganese or chromium or say iron or any other metal or non-metal mine, one can buy a universal one where it works in different multiple ranges. Now NASA and other agencies, they are also giving open source sort of library where a lot of spectral signature of minerals are available for research. Now this library is extremely good for someone to learn remote sensing and do say identification or develop algorithms, but it does have its own limitations. Suppose if you want to look for spodumene or if you want to look for all the lithium bearing minerals, it is not there. If you want to look for tungsten bearing minerals, it is not there. So it is in a broad way, it is a library that is available and people are using in academic domain. But in practicality, you must have a lab setup or a drone setup to do the work by yourself, because many of the spectral signatures which you need for your mine environment may not be there in the USGS library. And that is the biggest disadvantage. So we have number of platforms, the aerial platforms, aeroplanes, helicopters, satellite, fixed wing, and UAVs. And in UAVs, you may have flight regulations, but nowadays UAVs can possibly run below 30 meter. The coverage will be slightly lower, but then I think the new policy on drones in India, one can possibly check. But I think the last time I have read, you need flight, say the regulations. If you are below 30 meter, then you can possibly go without any special clearance. So what is the pros and cons? One of the biggest pros is that it is non-contact, non-invasive, non-destructive. It does not destroy your sample and you do not really need to touch it. So you can do it from close or from a faraway environment. It is extremely environment friendly because it does not make use of any chemical. It is extremely fast because once you capture the data in multiple bands, you can process it in your laptop as well. And then it is highly accurate in identification. And if you can make it a customized estimation one, it can work for you. It works in a micro, macro, or regional scale. And people in India and abroad have started to use these for biodiversity or environmental impact assessment or any such environmental management plan studies as well. The biggest cons, and particularly for us in academia, is the capital expenditure is really high. These equipments come in several crores, and the typical budget that is allocated to projects is like 40-50 lakh, where these equipments come in 2 crores or high. For a microscopic one, or for a lab one, for a borehole scanning, the core scanning machines or the aerial machines, they come in several crores. But the initial capital cost is there, but then the same equipment can be reused in multiple places. So in different stages of exploration, say G3 and G4, where you are trying to cut down from a say 1000 square kilometer to a 100 square kilometer or to a 10 square kilometer, this type of equipment is really useful because on the ground, it will take years to cover the big area. But these equipments can really help you identify the targeted areas where you should really put in your efforts. And the second con is obviously, since it is in starting phase, so a lot of customization is required because many of these companies sell you the machines, but they may not be able to sell you the specific algorithms to do a particular work. So a customization is required, and if you have sufficient knowledge about the working principles, it can be done. And obviously it varies with the illuminations and scattering conditions. And typically a natural environment is a mixed environment. So over there, you really need a specific algorithm that targets the minerals present in your area. The case example is the granite signature that is available in USGS library is based on the minerals present in granite in that particular environment in US. But if you scan the granite in India and again in different basins, they may have different signatures because the mineral composition will again be varying. So these are the primary limitations. So obviously hyperspectral remote sensing, as we have seen, it's really good in laboratory conditions because the sample is very close to the equipment and also in the field and in tripod and drones because they can now cover a larger area, and satellite data is also available if the area is inaccessible. So the initial G3, G4 type of exploration can still be done even if the area is inaccessible to you through the use of satellite data. Or the broad features or the biodiversity and other things which do not need high resolution can be done through the use of satellites. Satellites have their own use because of the broader coverage. So this is another example where you can see a mine, and these mines appear as oranges or yellowish in all the benches. So you can, an experienced mining person or a geologist can distinguish between a ore and a waste or the OB, but a machine can be fail-proof. So it can not only tell you the ore or the overburden or the waste, it can also tell you the grade. So in general, suppose you can say this is 30% iron, 40% iron, 50% iron, based on your experience in a working in a iron ore mines. But then the machine will tell you, say, 31, 32, 33 exact if you scan the particular area. So you only need to scan it, suppose in a tripod or through a UAV, and it will tell you the grade distribution, the impurity distribution in a mining environment. The same aerial drones are now being used for biodiversity assessment. So you can distinguish the different types of vegetation present in your area before the mine, during the mine, and say after afforestation, what is the distribution of specific species. And it also can help you document the impact of mining on the vegetation. Say one of the studies that is being done regularly in, say, suppose iron ore mines, is the dust deposition on the plants, nearby plants. So this kind of studies are, I mean, really, it can be done rapidly through the drone-based studies. You can easily find out the impact of dust on, say, this vegetation up to a certain distance. Or maybe in a open cast mine of suppose, or underground mines where you have lead and zinc. So the distribution of lead and zinc on the surface or its impact on the nearby vegetation can be studied. Now this is one example where you can see this is a human vision. So it's a yellowish flower, but for a honeybee, because it can see in a UV range, the features are different for a honeybee. So it can see many more features which are invisible to the human eye. So addition of one band can help you find many more features. And this is a simulated butterfly vision, which can again see in different wavelength. This is another example using, say, flowers. So you can always go to on the web, you will always find a UV photography. A lot of studios are there in India, may not be in India, but in Europe and USA, you will find some new startups or new studios have come up that will do the UV photography for you. To capture such, say, great differences in, especially in flowers and other things. So what it simply means is that some minerals, they glow in UV. So this is one example that calcite is very much distinguishable from the other type of minerals because they glow. And you can see in this one and the other one. So basically a honeybee can possibly see the calcite easily compared to a human eye. Or if you carry a specific spectacles and a UV torch, you can possibly see those UV distribution, basically with the help of a machinery or with the help of a Google Glass or Apple Glass kind of thing. So here also you can see some minerals, they glow in UV, so they are easily distinct. So this is what you see in a natural and the human vision, and this is what you see if you have a UV vision. So the distinguishing features are very prominent. So again, several examples are there. If you search in the web, a lot of minerals have been listed with good photographs, which are sensitive to UV light compared to other minerals. So they can easily be distinguished. So in the same way, if you want to see the same, so you can see these are fungus, but these fungus, you can see some are, say, oranges, some are reddish. So the variability, basically these are of different types, which in a normal human vision, it may all look like a fungus, but in a hyperspectral remote sensing, you can find out the diversity or the biodiversity that may exist in your region. This is again, suppose lithium bearing spodumene. This is what you see as a human vision, and this may be in a UV assisted vision. So this is a natural human vision, and this is a honeybee vision. And if you may be wondering that maybe humans should have a UV vision. So if you want to look human face in UV range, this is how it looks. So this is our normal vision, the RGB, red, green, and blue combination. And the moment you have a UV comes into picture, this is how it will look like. So what it simply means that honeybee may be seeing us possibly something similar to this compared to this. So maybe we have got a RGB vision which is possibly I mean, nicer than a UV vision. But then we also lose the details that may be possible with a UV vision. So this, I mean, this technology have been used and misused in a number of ways. So you can see one example. Recently, I have seen in newspaper that when you buy a property or a flat, you also give fingerprint, and the same fingerprint also you have given in a Aadhaar center. So people have used 3D printer to reconstruct your fingerprints. And since we have Aadhaar payment systems, machines are there where you give a thumb impression. It will, in a village, they have this kind of machines for villagers where a simple thumb impression can fetch you up to rupees 2000 in a single cash transaction. So it has really recently happened that many property buyers started to lose their money after 1 month because people have used these pictures and use this to create, say, 3D printers. So nowadays, many companies like Apple, so they are also looking for spatial fingerprinting. Suppose if you have a thermal camera, so those cameras can really read your, say, the dorsal veins. And this pattern that you see is unique for every human being. Just like your signature is unique to you, I mean, a thumbprint is unique to you. This dorsal vein arrangement is unique to a person. Because many of these, suppose if you have a face-based unlocking can be done through a face or it can be done through a photograph as well. So it is not foolproof. In the same way, fingerprint technology is also not foolproof because now a 20 rupees glue or silicone gel or a 3D printer can be used to, say, make a fingerprint that can beat a fingerprint scanner. And recently in IITs, they have implemented the attendance system using the fingerprint, but then students have used a 20 rupees glue to create a fingerprint on a silicone gel that can be taken as a positive attendance on a machine. So big companies like Apple and others are working to add some more features through UV or through infrared so that this authentication system becomes more and more foolproof. In the same way, we have thermal imaging. So thermal imaging is not separate from hyperspectral. The thermal imaging are usually wide band nowadays, but if you have narrow band, then these are again comes in the domain of hyperspectral imaging, and companies are looking to, say, utilize them in various ways, and one of them is obviously your authentication system. And this is also useful in many companies in industrial environments. Suppose if you want to know the temperature of a boiler, a lot of boiler, say, burst cases are happening, and obviously it leads to a lot of loss in terms of property and life. But these can be minimized because the thermal sensing, these cameras can really track the temperature and give you an alert before something really goes wrong. So these has a wide number of number of domains where this technology has its own use. The gem that you are buying, the, say, diamond that you are buying is a quartz, or whether it's really a diamond, it's a carbon-based diamond, or whether it is a silica-based, say, quartz, that can be differentiated, and many other gems can be differentiated without destruction. That is the primary thing. You do not touch the object and you do not destroy the object like in a typical other types of instrumentation. In study of soil, whether the soil is rich in nitrogen, phosphorus, and potassium. So this is highly useful for agriculture to not only know which type of crop will survive and how much of fertilization is required in a season. It's really good for vegetation, agriculture, for dust control, for gas pollutants. Some typical usage I will show you for current node and forensics and forgery detection and so on. So this technology is already in use in around the world, and maybe it will be available in your cell phone camera very soon, in a couple of years, if it has a UV band. So you can simply scan it and the algorithm will tell you whether the note is fake or whether it is the original one. Because typically notes are printed with dyes in layers. And in a printer machine, they are simply using RGB, the 3 colors, to print in a single layer, or maximum say 3 layers. So, but in a normal say notes are printed in multiple layers, and they have different dyes. Some dyes are also sensitive to UV, and some dyes are also sensitive to infrared. So that makes it unique, and then it becomes say fail proof to know whether it is a fake note or whether a real note. In the same way, in all the say paintings, especially very high value paintings, a lot of say imitations are there, and those are like printed ones, but one can distinguish from a printed one from a original one, because these original pigments that have been used to create those paints have been created in layers. So the painter has used suppose iron rich pigment, lead rich pigment, chromium rich pigments, potassium rich pigment, and different parts of the photograph have signatures of specific minerals. So basically you can now separate one picture into multiple layers, and these layers define specific element. So obviously the forgery in such high value arts can be avoided through the use of this technology, hyperspectral remote sensing. This is highly useful and being employed in developed countries like USA. They are looking for the nitrogen levels in the farms. They are looking for, say, moisture level in the farms, because irrigation also costs a lot. In US, the farm size, every block is like 1 mile by 1 mile. So their farms are really, really big, and obviously you pay over there per hour. So it becomes very resource intensive if you have to do it manually. So they have employed drone-based remote sensing for their farms to know how much of moisture is there, how much of fertilizer is there, or whether it is low in nitrogen or phosphorus and other, say, fertilizers, and one can spray accordingly, or the water or the fertilizer. This is also highly useful for minerals, because even if you are highly trained, you may not be able to see specific minerals, because colors or the hand specimen features sometimes can be deceptive. But if you see a machine, the spectral signatures and the algorithm cannot make that particular mistake. Suppose if you buy a apple, obviously apples nowadays are also have a edible coating, so that keeps the life of apple, increases the life of apple. But these edible coatings sometimes are replaced by wax from, say, the candle. So, but these are non-edible and can really cause cancer. So how to distinguish? So maybe in near future, when these cell phones will have a hyperspectral camera, you will be able to see whether it is coated or not. And if it is coated, it is edible wax or it is non-edible wax. You can also see a lot of other things like the sugar content. If you are a diabetic person, you really want to know how much of sugar can possibly be there. You can simply scan it, and it can tell you whether the fruit or the, say, bread or a liquid has how much of sugar. So it can also distinguish, I mean, natural things from the man-made things. So there you can see different leaves are there. These are natural leaves, and the one that you see is basically plastic leaves, because the spectral signature of polymers are different from natural vegetation. So natural vegetation has low reflectance in red and high reflectance in near infrared. So this jump that is there in natural leaf is never there in a polymer. So this simple difference, algorithm targeting this simple difference can really distinguish the fake ones from the originals. And this is going to be true for a paper or a textile, and say suppose cotton and rayon or so on. So it is a 20-80 or 80-20. The machine can possibly tell you in future. Because earlier, suppose in 2008, we used to have $100 laptop project. And people are nowadays targeting for $1,000 hyperspectral camera. Because obviously nowadays your Apple phones and many other expensive phones are coming in 2 lakhs. Suppose if a phone comes in 2 lakh or 3 lakh with a hyperspectral capability, they will really change the way you live your life. So they are extremely useful for vegetation, for type, health, whether it has any disease, and whether the disease is spreading with time, whether it has enough of water availability or water stress is there, it has enough of nitrogen or other fertilizers or stress is there, or if the soil is deficient in one way or the other. So many things can be captured at the early stage. So you can see that if you have any disease which is spreading through the plantation, normal one or a diseased one, they can be differentiated easily using hyperspectral remote sensing. And many farms in US have already started to deploy these. So these are all very customized solutions to detect particular type of disease. I mean, the technology can detect many type of disease, but the algorithm will work for the type for which it is trained. In some countries, you'll see that the borehole cores, which we typically store in our repositories as such, they are now being scanned by hyperspectral remote sensing cameras, so that if you want, suppose you have mined it out for iron, but you have never seen if there is any rare earth or other, say, metal of importance is there. But later on, you can always process. So anybody can process, one person, second person, or any person around the world can process your data to look for the presence of other minerals or economically viable minerals. So this has become mandatory in certain countries, that all the cores during the coring, when you have before a mine is being developed, you have a 100 by 100 or 50 by 100 or 300 by 400, such high density drilling is done. And you have a lot of cores come out, which are stored in, say, repositories. But these repositories are hardly accessed at a later stage, because it is very cumbersome to take out all those stack of cores. But then if you have a scanned picture of it, one really do not need to go to look for the actual samples unless you want to verify. But these can really be helpful in many such cases. Now, this is a picture I've shown you on the first slide. And here you can simply see that the three minerals which have, say, calcite, dolomite, say they are chemically similar, but you can see based on the response, they have been given different colors. So calcite is bluish, dolomite is greenish, and dolomite combination is given as red. So now you can see the distribution of the minerals in a, say, a mining region. And this gives you surfacial distribution. And obviously you can see that the blue and the red and the green zones are clearly demarkable. And within these zones, you can also find whether any structural or lithological controls are there or not. So such kind of studies are really possible. Now, what is important for you to notice is this is the RGB combination. Means if you have a simply human vision with red, green and blue, you combine them as a picture, this is what you get. So here you cannot really distinguish the calcite and dolomite. If you are a geologist and you can look the sample from close by, you can differentiate between the calcite and dolomite. But from far away, it is really not possible. And to scan everything manually is again very cumbersome task. But the same task is so easy that if you scan the area using a drone, you can make a really good map where the distribution of specific, say, minerals are possible. For example, if you talk about, say, manganese deposits in central India, Kansar and other mines, you will find that this manganese is actually surrounded by the calcite and dolomite. So you have a very good structural control, and then these manganese are surrounded by calcite and dolomite. So if the calcite and dolomite is there, most likely you also have the manganese also. So the surface expressions of calcite, dolomite and manganese can be mapped out. So recently one group came from there and they wanted to for us to do the mapping of the many such district blocks. They have come up with 20 such maps and they wanted us to use the remote sensing to this kind of work. So, but obviously to do this kind of work, you need at least, say, 4 to 5 crores investment in the equipment to really find out the areas where manganese is really project, because if the manganese is there on the surface, it cannot escape the eyes of, say, an equipment. But then unless you have equipment, you really cannot do it. So, I mean, nowadays, I think may not be companies, but some exploration companies have started to build labs with remote sensing cameras. So I hope you will see some advancements or real applications in Indian scenario as well. So the point is, this kind of equipments are really useful in exploration and also during mining. So this is another case where if you have a tripod based setup, so from 10 meter, 30 meter, you can scan the mine face in front of you. So you can find out the ore, the waste, the OB, or within the ore, you can find out the grade. So typically nowadays, the mining engineers or the geologist over there, they will pick up some samples and send it to the chemical lab. And it takes few hours, maybe by evening, suppose in iron ore mines, maybe by the evening, they get the grade, whether it is 52% or 56% iron or 48% iron. But then this equipment, say it may, depending upon the type of equipment, it may take 1 minute to 10 minutes if it is a push broom scanner or snapshot scanner. So, but then within 5 to 10 minutes or within a minute, you can capture an image and the laptop algorithm can process in a minute or so, and you'll see the grade distribution, and which may not be accurate up to the second decimal place, but it may be accurate up to the first decimal place. So what it means, suppose 50.1 and 50.5, you can distinguish. And in the lab, it can distinguish suppose 50.11 to 50.55. You may not have that much accuracy, but you really don't need that. So this is a really a good way to speed up the work. You visit the site, you scan it, you know the distribution so that you can control the output grid or the dispatch grid more accurately. So these are highly useful in a mining environment. And this is again very useful because these mine faces are fresh faces. On the surface, when you are scanning through drones and others, they are weathered minerals. So weathered mineral signatures vary slightly compared to a fresh surface. So once you customize your algorithm to detect a particular ore type or the one or other metals, it can really make those maps very accurately because the surface are fresh. So here you can see another mine environment where the mapping has been done, and you can see it is in the short wave infrared, so 2.1 micron to 2.2 micron, and you can always find out the sulfides or the regions with the chloritic or sericitic alteration. So if you're in geology, obviously in sudden deposits, or if you have a porphyritic deposit, porphyry deposits. In porphyry deposits, you'll find circular zones of sericitic or say chloritic and other zones. So these are highly useful to know what type of mineralization might occur and how you can possibly mine them, in what way the mine design can be done. This is a very good example where the points have been shown. For these points, the signatures have been shown. So you can see that massive sulfides and one with iron, volcanics with iron, or volcanics with chloride-rich minerals, they have typically different signatures. So this is your field spectra, and this is suppose in a drone. So they may vary slightly, but then algorithms are there to take care of these subtle variations. Minor variations can be taken care of so that you match the lab spectra, a pure spectra with a image spectra. So lab spectra is basically suppose a pure hematite, a pure magnetite, or a pure chlorite. But in the field, it may be mixed with other minerals. So that is why some variations might be there, but then you are able to map out the major zones. And this is where it is, say, it makes your work so easy. Here is another representations that helps you understand that you may have, suppose in Jharkhand, you have 2 or 3 major type of trees are there. So whether you have a salt tree, so if you want to map out the salt tree within the forest, the hyperspectral remote sensing can be really useful. It cannot be done with a Landsat or a Aster because they don't have the bands in the specific range where a salt tree is different from, say, a eucalyptus or say, or from a teak tree or others. So the teak mapping or the salt tree mapping can be done uniquely because this technology can map out, say, a banana tree from a mango tree to a lychee tree and so on. So they can be distinguished through this technology. So this one is already making inroads in other domains. Pharmaceutical industry is using in a big way to do a fake detection as well as quality control. So what it simply means, 1,000 milligram paracetamol and a 500 milligram paracetamol can be distinguished through this equipment and the proper algorithm. So the dose control or the quality control can be achieved. So many companies around the world are making use of it in the ingredients as well as in the final output. In the ingredient, what is the purity level? In the output, what is the, say, quality? And what is the control on the grade or the dose? The same thing is also used by many companies in the food industry as well. And a very simple product of 20 rupees or 50 rupees that you buy as a bread, that may have undergone, say, a lot of testing so that every piece of bread that you buy has a lot of consistency. Consistency in terms of the amount of fat, amount of moisture, basically the softness is similar, amount of uh, sweetness is also very similar. So many companies around the world are taking care of these very fine things so that you buy the same product in Kolkata or you in Chennai or Delhi or Bombay, if it is from the same company, you will have a very similar experience. And you will be amazed to know that a company like Indian Tobacco Company, the ITC, they are also working, and many other such tobacco companies around the world are trying to distinguish the tobacco in terms of the nicotine content, a low, medium, or high nicotine. So the same cigarette pack, because the ingredient comes from tobacco leaves from different areas may have different nicotine content, seasonally or from location. So now, after the production, you can really distinguish without burning or without any testing. This has high nicotine content, low or medium. So the companies can now actually make more money from the same product. And it is advantageous for them because the people will have a very consistency in the, say, they will find the consistency in the product. So it goes from all sorts of products, not only in mining and metal industry, but in other industries are making use of it in a big way. And these are some samples that I picked up from web, how a miniaturization might be possible. I mean, they are looking for different ways to separate the bands. So if it can be made in a 1 centimeter cube or 2 centimeter cube, it can possibly go into a cell phone camera. This is a pictorial representation of the same thing. You can have a drone that can first map out the moisture levels in a field or the potassium levels or phosphorus levels. And then accordingly, it can help irrigation or spray of pesticides or spray of fertilizers. And these are not experimental things. These are being done on a day-to-day basis in countries like USA, where big farming companies, where they have thousands of acres, they are doing this through special sensors which are placed in the field and through the use of drones. So it is a very simple setup for them because companies, when they are selling, they sell you a drone, they sell you a tab like one where the software runs, and after the scanning is done, it gives you a picture. So you really don't need a operator or a special person to explain the things to you because it is coming directly to you. So it's highly customized for a specific use. So you can see that it operates in a cell phone or a tab. So anyone, it is very easy to use. The same thing goes for a mine face as well. where you can detect minerals through handheld equipments or through a tripod scanning or through a drone scanning or through a satellite. So this is also being used in a number of ways. So you can see in Jharia and other regions, one program is running where they're trying to find out the total methane emissions. Methane coming from coal is a very big challenge nowadays because methane is highly potent in terms of global warming because they can absorb, say, heat, or they are more, say, they're more capable in absorbing heat compared to, say, CO2 per atom basis. So that is why people are trying to track the methane emissions from permafrost regions and from coal mines as well. But their approach is different. They are simply having uh, equipments that are trying to find out the methane near the surface. But then if you see the same pictures being taken by the hyperspectral cameras, they can really track how much of emission is there. So these can be a real documentation of how much of methane might be coming from a permafrost region or from a mining environment. So this has a lot of applications. This is another example. When you scan the web, I mean, you'll find a lot of example where hyperspectral technology is being used to find out the minerals. So in this particular case, they already had a mine, and when they scanned the nearby surfaces, they have found another big mine carrying lithium. So typically it is said in our domain in geology that everything that could possibly be found through surveying has already been done. But then this is not true for many of the rare earth or specific critical elements. The hyperspectral technology can really bring you big surprises. They can really find you if similar environment or similar setup is there in the nearby environment, and whether you have more deposits in the nearby areas. And one such example I will say is, say, in the Musabani and Surda region, the Singhbum Shear zone, where copper mineralization is there, and it is being also mined in number of companies. Many mines existed before they got closed, but they are again being opened after copper and say other minerals or other metals are more economical values there. So we have seen such signatures in the nearby regions where you don't have any mining. So we have done this through, say, USGS library and the AVIRS data that we have collected from the NASA repository. So the initial processing shows that few points does show presence of, say, specific copper bearing minerals, which are also there in a nearby region like Surda or Musavani and Raka and so on. So it is very likely that those regions which are tree covered or inaccessible now may also have the same type of mineralization. So we really need to explore using this equipment or setting up such hyperspectral labs for the purpose. Now, this is one example that I typically quote is the presence of phosphorus in, say, steel. The phosphorus in steel can decrease the quality of the steel. So obviously, the steel manufacturers want to limit the amount of phosphorus present that goes into the input. And obviously, the major input comes from the coal. But within the coal, it is, say, highly mixed environment. It is really difficult to separate the phosphorus from the coal. But then the other major source of phosphorus might be it is from the iron ore itself. So in iron ore mines, you'll find in a banded hematite jasper layers, you'll find silica layers are there along with iron rich layers. And within this, say, silica or whitish layers, you also have apatite layer. These apatite are actually have high phosphorus content. So if you can mine out those regions and separate the apatite rich layers, you can actually limit the amount of phosphorus that goes into the iron ore. So the overall phosphorus in the input to the smelter can be controlled. So this has been tested in certain environments. This is another case where vegetation or the suppose nearby RNO regions, you want to see whether a high grade environment exists or not. So these can be accessed if you have the equipment with you. This is another case where you can see the signatures of limestone and shale. They can be easily distinguished in a hyperspectral imaging because they have very distinguishing features. This is just to demonstrate you that different minerals, they have very unique signature. Like if you have 100 people working in your company, all of them have a different signature. In the same way, you'll find that all these minerals, even if they belong to a particular group, they have very specific signature. Say for example, clay minerals. A lot of clay minerals are there, and you can see that they all have suppose a particular absorption features in specific ranges, like these three big arrows. But then the exact wavelength at which they may be absorbing is slightly different. So what it simply means, you not only can read out how much of clay is there in your sample, you can also find out what is the percentage of kaolinite or montmorillonite or illite is there. And since say illite, kaolinite, they all have different properties. Some are sensitive to moisture because they can absorb more moisture and they're expansive clays. Some clays are resistant to temperature, so they can go into a brick linings of the smelters as well. So clay, based on its property, have different industrial usage. So you can always find out in a sample of clay whether this clay is rich in illite or 90% illite or 95% illite. In the same way, suppose gypsum. What is the purity of gypsum that is going into your, say, smelter? That can always be found. And again, the same is true for different type of species of trees. They all have different signatures through which they can be segregated. So these are some of the equipments in say 2010. This was say another equipment from ASD, Analytical Spectral Devices. This is bulk. I mean, you can have a powdered sample or a leaf or any other handled sample. It can scan the sample, but really do not know in a mixed environment. Suppose if a sample has a grain of quartz and feldspar side by side, it will read both the signatures. But now we have a camera which can give you a picture like your cell phone camera. So now if one point is quartz, if the other point is feldspar, you can distinguish this over here using this lab setup, which was earlier not possible. So this is again 1 nanometer analytical spectral devices, hyperspectral. These are known as radiometers, hyperspectral radiometers, and these are known as hyperspectral cameras that can give you pixel-wise, say, signature. And these are highly customized handheld ones, customized for a chromite mines, customized for a manganese mines, and so on. Because companies can make more money by selling you more such devices. If you buy 10 devices for your chromite mines, they will be useless in a iron ore mines or maybe useless in a lead zinc mine. So that is why it is better to purchase a relatively costlier, but it can work in any mine setup. And obviously those have better resolution, better accuracy in long term. They can be economical. So here obviously I've shown you in the initial graphs, you have a lab setup. This stage itself is movable, and this camera also comes with a light setup. So you have a lab where the light is controlled. The cameras are also fixed, so the tray can move. So you can not only scan a one sample, you can scan a linear array of samples. So this tray you can see this is movable, and this can be customized. So if you have, this can be 1 meter, this can be 3 meter, this can be 5 meter, and it can be supplied in a customized way. And obviously you can see these are some standards, some reflector standards. So you have 5%, 25%, 95% reflectance standards, so that you have a control on amount of the, say, light, and calibration can be done later on as well. And these are some tripods, tripod-based ones, where you can scan a vertical mine face and so on. But all of them actually produce a picture like this. For each pixel, you'll get a signature. And you can see the signature is from 400. This particular equipment, some equipment manufacturer produce up to 1700. some up to 2500. So the pricing will vary. Suppose if you want to buy for forestry, you really don't need to go for a 2500. Up to 1700, 400 to 1700, cost will be half of what you get for up to 2500. So at half the cost, you can work it out for in a forestry project. But if you have a mining project, other zones are important for you. So you must go up to 2500. If you are working with clay, you must go up to 2500. If you are working with quartz and feldspar, you must go up to 10 micrometer or say 12 micrometer. So this is one such handheld camera, which is now getting very popular. It has its own limitations in terms of the resolution. The spectral width may not be as high as those high-end cameras, but the prices are 4 to 5 times lower. And they have been used by different, say, academic environments to do the modeling and other kind of things. Now, this is again very good example that this is a optical image, and you can see different type of rocks are there. And if you want to differentiate them in terms of suppose quartz and feldspar, you can see that quartz and feldspar. So this blue line is for feldspar. So the quartz and feldspar, they have very different signatures, and they are distinguishable in this particular range. So this 8 micrometer to 12 micrometer that you see, they are really distinguishable. Means in a coarse sample, you can possibly see what is quartz, what is feldspar based on the various properties. But once they are very fine, you can hardly tell whether this is quartz or feldspar. But then in a camera, once you take the picture and once you zoom up so that you can see the pixels, now each pixel you can classify whether this is quartz or feldspar. Now this is so interesting because suppose if you buy a gem, this gem is made up of silica or whether it is made up of carbon, because carbon will have a very distinguishing signature. And if it is made up of pure quartz, because nowadays pure quartz based gems are also very popular, and whether they have impurity or not. So impurity can also be checked with hyperspectral remote sensing. So you can find out whether they are real ones or they are what they claim to be, and whether the purity is really up to the given standards. So you can find out the original and the fake ones. The imitations can be found out for not only this quartz or say diamond, but also for other gemstones. So gemstone certification can be really reliable with hyperspectral remote sensing. And the best part is it does not need to cut a small piece of sample to test it. It is non-contact, non-destructive. This is another lab environment. It basically shows you how quartz and feldspar are different. So here you can see a library, a dashed line is a library signature. Here you can see the feldspar, a library signature, and a feldspar coming from a sample. Now you can always see some differences from your, suppose if you have a pure feldspar and then a feldspar that you have got from your sample, they will have some differences. So that is why your algorithm needs to be capable enough to still map out the feldspar grains from the other grains and not only give you identification but also the concentration. So it is possible to train. We'll show some examples later on. The same thing has been done in the satellite images. So you can see this point has this kind of spectra, and this kind of spectra belong to a very specific set of minerals. And based on that, you can identify whether it is a particular type of clay or not. So here again, you can see that two spectra have been defined. One might be a lab spectra, other could be a field spectra. Now lab spectra, field spectra is not a perfect match, but still you are able to find out which minerals are there, because in a field environment, it might be a mixture of more than one mineral. So that may cause, say, some differences. But your algorithm, if it is made properly, it will be, or if it is targeting spectral zones properly, it will be able to distinguish. These are some cases where you can see the type of equipments that are available nowadays. you can see a core log on a table, and it will go in from one end to the other end, and the camera will scan it and save the spectra for each pixel on this or each point on this core, so that they can be analyzed at a later stage to look for specific minerals or specific metals. And this is coming from SpaceSim, but this is available from many such companies. So they set up very customized ones for your particular use. You can buy a tabletop ones, or you can buy a boxy ones where you have even better control on the illumination or lighting conditions. So that when you scan multiple, say, logs, your illumination conditions are standardized ones. So this is another example where you can see a pictorial image of the log and a hyperspectral based image of the log, through which one can separate different minerals. So suppose in this case, you can see kaolinite, calcite, or biotite, chlorite, amphibole, epidote, talc, and some other groups like phyllosilicates and others are distinguishable. So even if you are not looking for, suppose, kaolinite today, but maybe later on you can still map it out if you have this with you. So in future, I would expect that companies who are spending so much of money in drilling, they also spend a fraction of it to scan it so that they can make use of this later on. And obviously a lot of literature is available where all the minerals dividing into silicates, non-silicates, or oxides, or sulfides, and so on, and specific minerals, specific metals, they all have diagnostic features where they are available. The generalizations have been done in many cases, and which are more capable of distinguishing, which are less capable, which ones are easier, which ones are really complicated. So if you see the literature, a lot of documentation is there. So that can be your guiding principle to customize your application. This is a very good example of what we have done. This is a Fourier transform infrared spectrometer. So this is similar to a hyperspectral camera. It does not give you a picture, but it gives you a bulk analysis. So we have made, suppose, pellets, say diluted, say in this case coal samples, and with these pellets, once we have got the spectra like this, so you can see that it has number of such peaks, and suppose from 2.5 micrometer to 25 micrometer, it does have a lot of peaks. Some of these peaks actually belong to, say, sulfur, oxygen, and so on, say specific bonds. So these peaks have actually belong to specific functional groups. And if you target a modeling using these peaks, which are sensitive to sulfur, you can actually determine sulfur. And in the same way, in this case, this is for phosphor. These peaks are for phosphorus. So we have also been able to not only detect, but also find the estimate of phosphorus with 10% RMSE. In sulfur, I think we have got around 5% bias, which is as good as, suppose, a traditional one. In a traditional one, we typically go for a CHNS analyzer, carbon, hydrogen, nitrogen, sulfur analyzer, where it takes like one sample to burn and calculate the CHNS. It takes like 15 to 20 minutes in a macro analyzer. And if you have 50 such samples, it may take like 36 hours to start the machine. Then each one of them will run automatically and then cool down the machine. So it will take you 30 to 40 hours to know what is the sulfur content in your 50 samples. But the same 50 samples, if you make pellets, say 5 to 10 minutes each, you can actually get, then the analysis part is hardly a few seconds. So within, say, 3 to 5 hours, you can get those 50 samples. So it is highly economical as well, because in a CHNS analyzer, you have like, we have 8 to 10 such consumables are there. And you have to really keep the machine in running condition, you have to do a lot of work. But The FTR spectroscopy, it's kind of optical mid-infrared one. It hardly has any maintenance. And we have used it to find out sulfur in coal, which is say 0.1% to 1% or higher. Phosphorus from 1 to 10 ppm or higher. And also carbon content in coal. We have also tried for say gross calorific value. And recently we have also done it for coal. Coal has a organic component and inorganic component, particularly mineral matter. So we have tried to find out how much of mineral matter is there so as to calculate the ash content. And we have been able to do this with a say a bias of around say 5%. And we have submitted some of these for Indian patent, and we have published some of this for PhD work that our students are doing. So what it means that this is for coal, but then we are also targeting some specific minerals like vanadium and say titanium and so in our labs. Some students are working in this direction, but we don't have the hyperspectral imaging cameras. So we are trying to work with this spectroscopy that is available to us. This came from a DST FIST support, level 2 support to the Department of Applied Geology. And we have been able to actually demonstrate that this technology, if you make your algorithm properly trained and proper targeted spectral bands, you can achieve what you want to. So this is perfectly possible. It is perfectly possible to do this for mineral industry as well. This is another example. Suppose these lithium minerals, the spodumene, lepidolite, rubellite, these, I mean, because these are a reddish color, so somebody may take it for say flesh colored ones or potassium ones, but these are not potassium. So in a pegmatite, if you see these flesh colored ones, you may take it as say a potassium bearing mineral, but then these are lithium bearing minerals. So we have identified some zones where some pegmatites, we have 3 generations of pegmatites are there, and one of them really has say lithium minerals are there. So in the XRF, accidentally it has come, but then what was accidental can be made in a regular way. Means if you have the perfect machine with you or the perfect equipment with you, you can scan all the zones with a suppose tripod. Even if you don't go for a UAV, you can go with a tripod. You can scan all the pegmatites and come out where these lithium bearing minerals are being concentrated. So the controls and the presence can be identified. So this can be highly useful. Now many companies, private companies are also going into the critical mineral ones. So this technology is the need of the hour. They must adopt these technologies not only for their regular mining activities, for the major ones, minor ones will also be useful. This is another case where you can see the Gaussian, which are typically found in over the, suppose, a copper deposit. This kind of Gaussians are seen in Surda, on the top of the Surda iron ore mines, Surda copper mines. You will find such Gaussians are there. And all these minerals that are listed over here are also present in that location. So you can see malachite, azurite, cuprite, bornite, chrysoprolite, chalcocite, cobellite. These are there in the scattered way. So we have seen that if you have a proper machine, you can actually scan the area and find out which areas may have potential, say, copper mineralization. And one of the case example is because such mines from the exploration state to mining stage, it takes like several years and sometimes decades. But US has actually mapped out the entire Afghanistan, and you will be amazed to know that they have already identified many locations where lithium or iron or copper are there in plenty. The big deposits are being already mined. And obviously many Chinese companies are taking lead in that. So what it simply means is that the years of work can be cut down to a very, fast cycle where it will take much less time to start from exploration to the end stage. So I think more or less the time is up. So I think I've also shown you most of the things that I wanted to. I'll simply go to the last one. I mean, many such examples are there, so there is no end to it. So I would like to close it down with some summary that what we should do. We should actually build hyperspectral library of our mines, and these can be used in the mines for training and building customized solutions for those mines, not only for the major metals, but also for the other ones which are invisible at present. And obviously all the borehole cores should be scanned before storage. And these hyperspectral field survey can also act as a baseline if you are looking for a effect on vegetation or land or the land use, land cover, and so on. So both exploration and resource mapping or environmental impact assessment, this technology is a very good investment from the mining company's point of view. Thank you, sir, and thank you for your attention.
Thank you very much, Professor Prashad, for the wonderful presentation that you have made, making certain things very, very clear to a layman like me. Yeah,
Thank
speaking
you, sir.
about
Thank you, sir. Thank you,
spectrometer,
sir. Thank you,
well,
sir.
it's been very useful and very nicely explained. I'm sure all the participants will agree with me that they have been richly benefited by this presentation. Well, there I can see number of questions in the chat box. You can one by one try to answer, but by 4:30, it's already 4:30 now. We'd like to finish to give them a 15 minutes break so that 4:45 we can start the next session.
Yeah, I
Before I
think.
give you for the chat box, I have just one small query.
Yes, sir.
You have mentioned about the Bonnie-Claire mine, lithium mine, and you said the adjacent there was another lithium deposit. So it was easy to correlate to and map them. Now my question is very simple. It will be very interesting also that whether we can use this technology for mine boundary disputes where the boundaries of the minerals on either side are same, not different minerals. If it is different mineral going on the bandwidth, you can easily find out. But if it is the same mineral, same bandwidth on both sides, is it possible to do to help out the people in mine boundary disputes?
Yes, sir. You can actually see the surface expressions of the minerals and find out the, I mean, continuity of one mineral from one point to the other point, and along with your structural or lithological expressions, you can find out whether it is a continuity of the same thing or it is something different. I think that is what you mean. So it
Yeah,
can
that's
be.
what I wanted to find that out only because there have been many disputes on mine boundaries in the field as we see. So I just wanted to have this clarification whether we can use this technology for finding out about the mine boundary and sorting out their disputes. I
Yes,
think,
sir.
yeah, you have clarified. Thank you very much. Now there are some questions I can see in the chat box. If you
Sir, if the
can,
time is not enough, they can call me later on my phone,
yeah,
and
yeah, yeah, I'll do
happy
that.
to answer.
I'll give you contact. But then maybe we can take another 2 or 3 minutes
Yeah,
and
sure.
finish off before the next speaker starts. Yeah. Yes, sir. Chat box.
Chat box. Let me see. Okay.
Sir, I have one question, sir.
Yes.
Sir, for R&R and replantation work, rehabilitation work, whether we can use this technology for checking the soil fertility, sir?
Yes, definitely. Soil fertility, say in terms of carbon content, say humic content, or soil fertility in terms of phosphorus or potassium and others. Actually, in our lab, we have tested the potassium for sulfur, and we have got some good results. But obviously, presence of say potassium or phosphorus or carbon in soil as well. So the soil fertility can be addressed.
Sir, another thing, sir. What is the
One
adverse
by one,
effect
please.
of...
One by one. Yeah, Mr. Bonar. Anybody asking a question, please. First, identify yourself, then ask the question. It'll be easier. Yes, Bonar, go ahead.
Sir, what is the adverse effect on it, sir? Agriculture and food industry, they are saying to that there we can, it has an advantage on it, sir. What is the adverse effect on it, sir?
See, you are not touching the samples, and these radiations are basically solar radiations. So these are not an active remote sensing. This is passive remote sensing. So in no way you are actually doing any harm to the environment. So that is why it is extremely environment friendly.
Okay, okay, sir. Okay. Thank
Yeah,
you, sir.
anybody else? Dr. Pani, I can see one of
Sir.
your queries. Mr. Satbrat
This is
from the
Pradeep from
NTPC.
Bridger.
Yes.
Sir, can we use this technology in land scheduling, sir, for better and efficient
In scheduling of what? If,
land scheduling, sir?
sorry, I'm getting broken voice. So that is why.
Land scheduling work, sir. For land scheduling.
Can you be a little more specific, gentlemen?
Can you rephrase your question again?
Sir, can we use this technology in land scheduling for in survey?
I mean, what kind of work you see means in scheduling land? So, I mean, land survey scheduling, you are saying.
Yes, sir.
So, what you are targeting here in your schedule? The components.
Sir, majorly nature of land, sir.
Now, suppose if you want to make a baseline for the land cover and land use, what type of forest or tree cover or crops exist, or what type of say fauna or the fungus type of things exist, you can always do the survey and the record will be helpful as a baseline later on once the mining actually starts. So I don't know if this is what you mean.
Yes, sir. Yes, sir. That's
So
it.
this can actually act as a baseline. People are using it as a baseline.
Okay, sir. Thank
Okay,
you.
gentlemen, that's all the time we had for the question answers. It's already
Sir, last one question,
4:45.
please.
I think we
This
can
is
find
Vinayak
the
from
questions
ERM group,
afterwards.
sir.
Yes.
Sir, this can be used in slope stability purpose.
See, slope stability depends upon a lot of high. Suppose if you are looking for moisture content on the surface, because it will only give you the moisture content on the surface. So, sir, moisture is a big parameter in your stability modeling. So that is possible. But other than that, I don't think all the other parameters really depend on remote sensing.
Okay. So it not replace the radar. Only the moisture content, other things we can know from this.
People nowadays are going for laser-based DM generation and hyperspectral also. So that laser-based DM can give you a really good slope, say, analysis, and that is a big part of your slope failure modeling. But otherwise, hyperspectral modeling is not very useful for slope stability part.
Okay, thank you, sir. Yes.
Thank you, sir. Thank you very much for your explanation and clarification to the participants. If any participant still have any more questions, you can please send it in writing, either to me or to Professor directly, and we'll see that you get your replies. That's all the time. We don't have much time. The second speaker he joined, and it's already 4:37 now. I think we have to cut down your rest time to 10 minutes. Within 10 minutes, we join, and by 4:45 we'll start next session. Okay, gentlemen.
Thank you so much, sir.
Thanks. Thank you very much, sir. And may I request all the participants to please switch on your video so that we can take a nice shot with Professor Anup Prasad. All participants, please switch on your videos.
Sir, chat box questions are not answered, sir.
You can call me separately. I will be available on the phone.
Yeah, all participants, please put on the videos. We can take a quick shot with Professor Prasad and then close the session because the next speaker is waiting now already. Mr. Krishna, Mr. Shekhawat, may I request you to scan the video, please? Okay, I'll take a quick shot, and with that, I thank very much Professor Prasad for the wonderful presentation you have made.
చెప్పండి చెప్పండి అక్క.
Thank you, Dr. Prasad.
Thank you, sir.
అదే చెప్పారు కదా అక్క, 4వ తారీఖున కదా. ఓకే ఓకే ఓకే. అలాగే అలాగే. అలాగే.
Okay, thank you very much, everybody.
Thank you,
We'll
sir.
now close the session, and 4:45 we'll meet again. We have very short time, but then we have the second speaker waiting. Okay, thank you. Thank you
Same link,
everyone for-
sir.
Thank you.
Sir,
Yes.
excuse me, sir. This is the same link I join in.
Yeah, same link for joining next session. Yes, yes. For one day, one link. Yeah.
Okay, sir.
Okay, thank you, gentlemen. Good evening, Dr. Abani.
Can you hear me, sir?
Yeah, Dr. Abani, good evening.
Yeah, good evening, sir. Sorry,
Another
I
10
have a
minutes.
very
I think we have given a little time to the participants. Let them take a little rest and come back, and we'll continue with the second session with you.
sure, sir. Okay.
Thank you. So, welcome back, friends. I hope all have joined back.
Yes, sir.
So, shall we start the next session?
Yes, sir.
Okay, I can see still about 7,
Yes,
8
sir.
participants joined. Only 33 have joined. Okay, anyway, we'll start at only 4:45. Otherwise, we'll run short of time afterwards. So, good evening, everybody, and good evening, Dr. Samal Abani Samal Saab. Thank you very much for joining from a long distance and addressing the participants here this evening. I extend a very, very hearty welcome to all of you. And before we start the session, let me give you a small brief introduction of Dr. Samal. That is his qualification. He holds a PhD from Carbondale from USA, MS from Imperial College London, and MTech in Mineral Exploration from IIT ISM Dhanbad. Currently, he is providing consultancy services to exploration and mining companies, government agencies, major financial institutions worldwide through Glow Global. He's the CEO of Glow Geo Global Company. These are the basic technical specifications. Dr. Abani Samal also serves as a council member of MEAI and a member of the editorial board of MEAI. He also serves in the editorial boards of the international journals Mining, Metallurgical, Exploration, and Natural Resources and Research. Gentlemen, I'll not take much of a time. We're going to give more time to the speaker because he has a long way to go again, and we'll have the time very, very short, limited. It's up to 6:15. So, Avani sir, you can please start. The floor is all yours.
Sir, can you see my presentation in
Yeah, it's
presentation
visible.
mode?
It's visible. Oh, yes.
Oh, good.
I can.
Good evening, everyone. Sorry, I have a very harsh voice this morning. It's 4:15 in the morning for me. Thank you, Bidati sir, for inviting me to make this presentation, and thanks for the introduction. One of the slides I always carry with me is my introduction slide. One thing actually I would like to use this slide in today's presentation is my CP and QP qualifications. I think that's one of the topics we're going to touch towards the end of this presentation today. And feel free to ask me questions. But these are so time we have 90 minutes, isn't it? I'll try.
Yeah,
to
you have 90
finish
minutes. Yes, sir. Yeah.
Okay. So today's topic we have is resource and reserve classification and reporting. Let me just remind you that broadly this presentation will be on two parts: water resource and reserves, and public reporting. Many of you probably know that I do resource estimation. It's kind of my professional work every day, pretty much, in different types of projects that we do. We are not going to cover how to do it, rather introduce what is resource, what is reserve, some terminology, and I'm really emphasizing on what is it reported, how it's reported worldwide type of thing. So let's dive into it. This is broadly the sequence of the topics I'll be covering today. Some of the slides I have, there are a lot of text in it. This is also will be shared with you from Vidyarthi sir. When I have a slide like this, please pay attention to only the highlighted text, like it's either it's bold or inclined, or underlined words. I think that's how we can cover this, all these slides that I have and the topics that we are going to discuss today. What is mineral deposits actually? Before comes the deposit, that's something else actually we have is mineral occurrences. Mineral occurrences is basically if we know that something is there type of thing, but it's not deposit. Deposit, the term comes when we know, or at least we can say it is big enough and enough for good quality. For an example, if you like the last presenter said, you take a scanner and find out there's some sort of mineralization, let's say, close by to your residence where you are, but that may not be a deposit actually. Once you find out, okay, it's big enough and good quality, then we're talking about, is it worth actually opening this mine in here? That kind of thought process comes to your mind. And in the foreseeable future. So it has economic importance. These words are important there. So occurrences and occurrences to deposit means we're talking about, from a economic standpoint there. Now, once you think there is a deposit, once you figure out, okay, there is a potential for a mining activity to happen, portion of the deposit may become resources. I'll try to clearly highlight one bullet point there is this. See, the location, quantity, grade, or quality, or continuity, all that is known, and then we can call it a resource. How we do that? Take all the material that we discovered, or we call it deposit, and see which part of the deposit really meets the criteria for reasonable prospect for the eventual economic extraction. I'm going to refer to these 5 words as RPEEE throughout this presentation. When I say RPEEE, that means reasonable prospect for eventual economic extraction. And I'll discuss that also, what really that means. Okay, just hold on. Then part of the resources that is economically mineable, that is, I underline the word is, that means in current time. By current time, I mean that you can foresee, that you can calculate, that your shareholders can see that if this mine occurs, if this mine happens, there is an economic benefit to the shareholders, or there is a benefit really coming from the activities to the stakeholders there. So that kind of when we justify that portion becomes reserve. So these are really technical words, should not be used lightly at all. At least from after these lectures, if you like have any doubt, please let's clarify. But resource and reserve are 2 different things. Now, before we actually go more details into it, I think we should understand what are the studies. In developing any mining project, this is how I have defined for this presentation what a project development really means. What's the kind of a life cycle of a mining activity really means. It starts from the exploration. I divided that into 2 different stages of exploration because in the preliminary exploration, sometimes we may or may not do studies. It's just the discovery It is just we are defining the deposit type of thing. We may not do any study. But as we progress from the preliminary exploration to advanced exploration, that means we are really defining the size and shape and quality and all different characteristics of a deposit. We are actually kind of standing there saying, okay, we need to do a scoping study. PEA is a preliminary economic assessment, and that is a Canadian regulatory term, very, very popular. Scoping study is also in Australia, in Asia, that's the term is used. And in the United States, they call it a different word. It's called preliminary assessment only. There's no economic something like that. So, but they mean exactly the same thing. Okay, it's just different terminology in different parts of the world. Once we do that, we are preparing ourselves for the pre-feasibility study. I wanted to stress something in here that when you say pre-feasibility study, the word pre really means we are not at a feasibility study level. Feasibility study here really not a dictionary word. It is the way it is defined in technical codes, guidelines worldwide. When we do the pre-feasibility study, starting of the pre-feasibility study really is the end of the scoping study. Something I would also like to mention here, one can go and do the scoping study under one management, under one ownership of the property, of the deposit. One can go and continue doing the scoping study number of times, revise it, and when they're ready, they go to pre-feasibility study, because it's an extensive study. This is really beginning to end, that they should be really drastically different. But entering into PFS, when you enter into PFS, what you know, when you finish the PFS, it should be really, really drastically different. In some cases, some aspects of the project may be way too mature during a PEA. You may not see that, but what I'm saying is, what you knew about the deposit, about the, whether the decision to be made, whether this mining process is gonna happen or not, at the beginning of the PFS, you should be able to get that answer towards the end of the PFS. So at the end of the PFS, we are really preparing for the feasibility study. At the feasibility study, we're thinking about, okay, how are we gonna mine it? How are we gonna, really main thing we are stressing here is CapEx, capital expenditure. So that's a big decision to take. So that is just, once you spend it, it never comes back to you. It becomes sunk money. That's why end of the PFS is always, in my works and worldwide, this is really something that should be taken very seriously. Why these studies are done? Is because I'm going to stress to this yellow arrow there. From the scoping to feasibility study, we change the definitions. Like in the minutes ago, I was talking about resource reserve. We gradually change the definitions of the mineralization. The most important thing is we decrease the risk by doing what? By actually, getting more information, and really this process of studies takes from the deposit to resource reserve. And as we will discuss, I will see, when you have a reserve, that means you have a lower risk of investment. Okay, and with more knowledge. So that's kind of left to right. Again, what we are discussing in this class, or this session, is mostly actually on this resource and reserve estimation. Throughout all this process, something that consistently goes on is resource and reserve estimation. Okay, and that's become the basis for making the decisions. The resource and reserve, the terminology I'm going to use here, is coming from any Crisco family of course. You can take, the course can be the JORC. It can be, in India, we use EMIC. It can be 43101, it can be SAMREC, and it can be many others like PORC in UK type of things. And they all use a simple two-dimensional diagram. There are 6 terms in here. One is exploration results. That's the first term. That means no resource in there. Then 3 different types of resources and 2 different types of reserves. So basically 5 different classes of resource and reserve process exploration results. There are 6 different terminologies are used. And like I've already defined, resource to reserve is basically, resource means in the future is mineable. Reserve means in current time it is mineable. So when you call resource, and these 3 classes are there, they are based on the increasing level of geological knowledge and confidence from going from inferred to measured, going to, for resource to reserve. When we convert that, we can only take indicated and measured resources into reserve. And here's something actually, when we take from resource to reserve, we use the modifying factors. Again, I'll give a little more details about that too. Like I said, throughout this process of developing a deposit and going into mining and continuing to mining, we all do resource reserve estimation. Okay, it is always a stepwise process. I always put that in like these 6 boxes in here. Starts with the data collection. Geological modeling, what I mean by that is basically interpretation of our data. Okay, it can be, maybe pictures that come to your mind is a 3-dimensional geological interpretation of the rock types or controls of mineralization in a deposit. Maybe that that and exploratory data analysis is that kind of go one-on-one. At kind of you do these are very iterative processes. You do the geology model, then exploratory data analysis, actually try to understand, if my data is giving me all the information that is required, not what you wanted. That's required to go to the next step, that is block model and resource classification. Ajin, we all probably know that we spend a lot of time in the block modeling, using various softwares like in India it's Saltpack, Data Mine. Recently, Vulcan is making some entry there, and Micromine, Leapfrog, all different softwares are there. We spend a lot of time in the resource modeling, but remember that to get there, we have to actually continue, have like 3 different steps there. And once you finish the resource, then we can go to reserve. So you can take these 6 boxes and put them in 3 different baskets actually. It's data collection, and then estimation, and basically interpretation, estimation of grades, whatever the commodity may be, uranium to diamond to iron or whatever that is. And then go into estimation. And one of the main things is that we're going to talk about today is reporting. And basically, what we estimated, is that all you're going to put in the report or not? And what is really required there? Just revisiting this sequence there, I added construction there because this is where we put the capex there, right? And when you do the resource estimation in all these in these processes, resource estimation you do all the time. However, as per all these codes, including in India, we use EMIC or JORC or SAMREC or PORC, all these, codes that is accepted in the stock exchanges to raise funds. In all those, you require at least a pre-feasibility study to declare reserve. At least. In some projects, I was directly involved. They combine pre-feasibility and feasibility study together. And you can do that, but you have to look at the local, in that country, in that jurisdiction. Also, what is the regulatory regime is talking about. Sometimes you can go from scoping study to feasibility study. However, you need that study to declare reserve. There is no exception. You have to have minimum pre-feasibility study. I'm not talking about the beginning of the pre-feasibility study. The red line shows that you have to end the pre-feasibility study. So at the end of the pre-feasibility study, it is required to have declare reserve. The terminology, if you open like any modern code today, you see that they define the study in a way that you are required to declare reserve to end a pre-feasibility study. So you cannot have a pre-feasibility study without declaring reserve. If you go to definition of reserve, they would say, well, you have the minimum pre-feasibility study to declare reserve. So they're kind of tied together. A little more details about resources. Like I said, let's talk about what is reasonable prospect for eventual economic extraction, or RPEXPPL is. Reasonable prospect really means the deposit that is under construction, the portion of that, under consideration for mining, the portion of that deposit should be should have the economic viability in a foreseeable future using reasonable assumptions. Really, reasonable assumptions refer to technical and economic assumptions. For an example, we know the gold price is going to, $2,500 today, around there. We had $2,700, but can we use the $2,700 and say, hey, it's going to be $2,700, remain like that, in 7-8 years time? We just don't know. Is that reasonable assumption? That's the question a competent person or QP has to ask and justify it, actually. We'll talk a little bit also what are these reasonable assumptions may mean, or the other economic criteria. For an example, you may have a scenario where you need a lot of capital, and if you want to use less capital, is a reasonable. And this has to be really reasonable assumptions. By reasonably mean you can justify it. You just cannot assume it. If you assume it, you have to justify it. The other three letters or E's there eventually really refers to a foreseeable future, the time, and it has to be economically extracted. That means mining should happen. So we cannot, we have, when we talk about resource, remember that we have to think about mining. It's no more that you have a geological interpretation and all the stuff inside that geological interpretation is going to be mineable. This slide is a lot of text there. Sorry, the numbering kind of got screwed up in this slide. I don't know why, but just look at this criteria that we're using here: geological parameters, engineering parameters. And engineering, when you talk about dilution and recovery, then infrastructure, ESG, marketing. Last two parameters, I have a lot of questions from there, is technical, economic, and political, right? Is that something that you have to consider for declaring resource? My answer is bold yes. For an example, we're dealing with a property in South America where the regime or the country doesn't allow us to, or allow this project to have an infrastructure that is actually for the transportation of the material that is required to have the, get this mining project successful. And we know it. it is not that, is hidden document. It is known. When you know that it's not doable, basically you cannot extract the material. You don't have a resource. You have a property, you have a deposit, is fine. You just cannot declare the resource, and in the Canadian stock exchanges. So we dealt with that a couple of years ago, a scenario there. So to simplify, what happens actually, the rest of the material that is not resources. On the right hand side, I just have a cartoon. Let's say that box is all the inventory of mineralization. We just don't know which portion is going to be resource or not. So the resource is not an inventory of all the mineralization drilled or sampled, regardless of cutoff grades, likely mining dimension, all this criteria. You just can't do it until you apply the arbitrary criteria. So you're saying reasonably this deposit can be mined economically. Then the portion of the deposit that meets that criteria is going to be resource. There are many deposits I have seen where the entire deposit or most of the deposit has become resources, and those are mining projects. That means mining is already happening. In the exploration projects, almost all the time, the resource is just a subset of the total inventory of mineralization. So now RPEEE is required for the resource classification. You just have to justify that is mineable. These are the criteria assumed in the scoping study based on examples and experiences. But when you come to PFS and FS, that kind of resource that you have at that stage, it has to be tested and verified. I'll give a simple example. We're dealing with a couple project here in Arizona. They use density based on rock types. It's very common, isn't it? I mean, and in iron ore stuff, this is great. However, when you looked at the cores, that density really changes in the same rock type. It changes based on the intensity of alteration and the type of mineralization they have. So we actually held that project. So you don't have a PFS because we do not know the density, because we don't know the density properly. We just don't know what is your ore waste classification is going to be. We just don't know. Well, because your density is not there properly identified at a PFS level, we just cannot clear this project for FS. So CapEx, we just cannot do it. And density measurement doesn't take too long, but it requires a campaign to do that. It's not the grades. You have to look at every aspect of it. Modifying factors are really based on real data. RPEEE and modifying factors are pretty similar criteria, like engineering criteria, geological criteria, economic criteria. But when you're taking resources to reserve, those criteria are real. For example, a land holding issue. In a resource, when you're declaring a resource at a scoping level, you can say, well, we will have that land under our control, or it will be bought, or we'll have that, But when you're going to reserve, we have to see the documents that you have it. So there are many of them, many examples like that. So these are the variables that makes portion of the resource reserve. So you'll see once you apply those criteria, only portion of the deposit becomes a reserve. Now, in this slide, what I'm showing here is, let me see, I can use a pointer here. On the diagram that you were seeing here, these yellow and blue boxes are the potential for classification of resources. And the red lines that you see, these are basically geological domain. In that domain, portion of the mineralization will be put as resources in a report that will be filed in Canada and America. And also this company wants to take it to Australia. What we did actually, we said, okay, is it really all mineable? So we put a pit cell there, the cyan color or light blue color outline you see. It's a pit cell, it's not a mine design. It's a pit shell. You may have heard like an optimized pit shell using many software that do that. When you put that, only portion of the deposit that was within that pit shell become resources, and we took that and put that in the report. Okay, X amount of indicated resources, Y amount of inferred resources that is going to report. Then what happens to the rest of the material? These are the portion of the mineralized material outside the life of mine pit shell. It's not a design. It's not a mine plan that doesn't qualify as pit assets. So hence, this becomes geological inventories. What happens in underground scenario? You use the technology, what is called MSO, that mine stope optimization tool, doing the similar stuff. Here's an example I found where it says, okay, we take the underground mine planning as an underground scenario here. The first shape that you're looking at here on the left-hand side, if you apply a cutoff grade of 0.55 copper, that is a lot of material that can potentially be mined underground scenario. And this particular case, we're actually testing this deposit going from PEA or scoping study to PFS. And at this time, we say, okay, what is the resource then? If we go for higher cutoff grade, that means if the copper price goes down, if the cost goes up, we have to mine a higher cutoff, apply the higher cutoff grade. The resources eventually shrinks. What happens here? What we see, these materials in here on the right-hand side of this diagram, they become so discontinuous. Really, you cannot make a underground development there. We really have to cut it off. Okay, you cannot really justify that. The small portion of that is mineable. Remember, arbitrary criteria, the last is there. They say whether it's mineable or not. We already covered that actually by the resource reserve. There's just some what reasonableness really means. On the left-hand side of your slide, what you're seeing here is a yellow kind of solid within which there is a red solid there. This is a gold project I think I did about 15, 16 years ago. And while we're talking that, the green and the red solid on this diagram here is actually, these are the ones, they are well defined using their drill data. But the yellow ones, actually, they are extrapolated. I'm not saying it's wrong. This is interpretation, by geologists, qualified geologists, but that's not supported by data. So we ended up actually just taking the red stuff in here and basically test the arbitrary criteria. Portion of that becomes research. So geological interpretation, yes, we know we are geologists, we have assumptions, so we have imaginations, we can justify geological, but when it comes to reporting, please show that you have intercept in the drill hole data. On the right hand side, that diagram, what I'm showing there is an automated type of interpretation by a geologist. It's entirely based on the criteria that is used to create a geological dimension. This portion of this deposit actually, or this mineralization is, where we struggle a lot, a couple of weeks actually justify, is it really part of the deposit or is it different geological system, right? And so what is reasonableness in the geological interpretation? We really have to really see if this interpretation is gonna be, we can carry on, or as we go into PFS, is it gonna change? And yes, in many cases, or I'd say in majority of the cases, your geological interpretation should change. The reasonable processing engineering, right? Sulfide versus oxide dominated copper zones. You can probably just see these two drill hole intercepts. Guess what? They're from the same deposit. One side, a little bit here is a mixed type of mineralization. Here you have oxide and very high grade sulfide here, and here is a majority of the material that is sulfide. Now, when we talk about resource, basically, I was the CP on this particular project as well. What do process guys say? what is the recovery is going to be? You see, are we going to take everything? Do you have a leach pad? Do you have the land, right, for that? So we have to take the opinion of the process engineers, and sometimes the metallurgists, or both of them, both of the disciplines heads or leaders there, and say, hey, is it really doable? Is it reasonable assumption that the recovery is going to be, the way it is presented to us? Now, this is also another project I'm going to show you in a copper type project. Acid soluble copper and cyanide soluble copper. There are two different types of processing in here. In this diagram, what I'm showing you here is, the blue line is as you increase the cutoff grade on the x-axis, you see of course, there's a less and less amount of total copper. This is MLB is basically millions of pounds of copper in North Africa. So North America is most likely millions of pounds. That's how copper is, put in the report. What you see there is, as you increase this cutoff grade in this particular scenario, we see that the acid soluble material goes up. That tells us something, that we need to actually understand, okay, apply the cutoff grade, we are reducing the amount of copper, but also at the same time also seeing that the processing criteria has to change. What really that implies? That you may actually want to actually put a process plan and a leach pad together, but what is the capacity of those? So those kind of details will be figured out in the future, but we have to first accept that this type of engineering we're considering and declaring a resource. Here's another scenario. What is a reasonable prospect in here? This is a gold project where we have let me go back, sorry. This gray line is the pit that we have it here, and in this particular project. And this project, the mining activity, was stopped 10 years ago. Now we're looking at a higher gold price, and can you mine it or not? So we're looking at various pit cells. Which pit cell we're going to use to declare resource? And this purple one, there's a cyan color one, there's a yellow one, there's a red one. Which one? This is one cross section, but if you look at three-dimensional space, there's a substantial difference. I want to draw your attention to this portion here. As we go to one scenario, you see that the largest bit, the red one. If we take that scenario, there's a lot of gold we can report. But let me show you something. This is kind of the grade distribution. Hotter the grade, that means this portion is actually what you are targeting in this mine. You have to go deeper. But if something interesting is always all the time is flattened there. That tells me something else. And basically here is some grades we cannot achieve unless the gold price really goes up. Here's something interesting. We see that the base case scenario, this is on the right hand, the left hand side of the diagram, you see the ounces of gold in here. That's kind of ounces of gold we have. That's the base case scenario. So then I have like 15 different types of scenarios. We were looking at all scenarios that various types of engineering parameters, not the geology parameters changing. When you go from the base case to a realistic scenario, that is high processing cost. This is actually this is a current project we are looking at. The best case scenario was 2020, 2021. After that, we had COVID, remember? After COVID, things have changed drastically, and it has affected mining industry worldwide. The cost of mining has increased substantially. Processing costs are substantially increased. You need materials to make it mineable, that is actually has substantially changed. So higher cost means lower amount of gold, gold we can mine. As you keep increasing the gold price, we're saying, well, today's price if we take this in a scenario 15 or 15th model should be okay, but is that sustainable? Can we really say that $2,500, $2,700 gonna stay there? Probably not, right? So we have to change the price as to what is a sustainable price to test actually which of these bit cells we can use to declare the resource. Now, that's kind of what we say, what is resource and reserve. But a little more detail about inferred indicator and measured resource. So let's start with the inferred resources. Again, like I said, in this slide, there's a lot of text. Just pay attention to these bold lines and underlined words. Vidyarthi sir, how much time I have now? I kind of lost track of that.
Sorry, I was on mute. You have time up to 6:15. You can go comfortably. There's no problem.
So, okay, thank you. So, the inferred resource really means that we have limited geological evidence and sampling. Limited, and we have sufficient to imply but not verify. Imply but not verify the geological continuity. Okay, and now it is based on the exploration, sampling, and test information, of course, but it's limited. There's other underlined words in here. There's a lower confidence than the indicator resources. Now, when it comes to indicator resources, look how this wording changed. It's from limited to, it says, well, it has to be, all the data has to be derived from adequately detailed and reliable exploration, sampling, and testing. Okay, and this is sufficient to assume sufficient to assume to make decisions on whether that portion of your deposit can be confident reserved in the future. So it's no more assumptions. Actually, you can't just leave it alone. You have to actually say, okay, it has adequately and detailed analysis, sampling done. You have a detailed interpretation done, and reliable expression. The reliable word is inserted carefully and with a lot of discussion here, and it's sufficient to assume geological and great continuity. The sufficient is a very subjective word here. What sufficient really means? When you use the word sufficient in this context, so remember, part of the indicator resources can go into reserve. That's the first underlined words in this slide. It says that you can apply the modifying factor. That means you can take it into reserve, and so that is very, very important in here. Okay, modifying factors in here. So when you go from info to indicator, that's the type of changes we're seeing. Okay, and indicator has a lower confidence than the measure that we know. Measure is here, actually it's measured resources here, indicator lower confidence. Now, only part of the indicator resources can be converted into probable reserve. That purple arrow there is not compromisable. You cannot take any part of indicator resources into proven reserve or proved reserves. Now, when you come to measured resources, you have a sufficient confidence. That means we are using the word confidence here with a lot of stress there. If I go back 2 slides in here, say in the infer, we said sufficient to imply but not verified. Indicator, we said adequately detailed and reliable exploration data and is tested. Here we say measure is sufficient confidence that you have. I can take all of that into reserve, right? The second bullet point in this slide, it says that it's from detailed, reliable exploration, sampling and testing, sufficient to confirm That's a strong word here. It's no more assumptions. All the assumptions you had and inferred, you have to test and verify it. Okay. So when you go into major category resource, part of the major category resource can be probable to probable reserve, and part of the major resources can be proven reserve. When we have a major resources, if any one of you is a QP or CP or practicing in this resource reserve area, I really caution you that be very, very careful when you say major resource. That means you're telling the readers of your report or your company executives or your shareholders that I have so much confidence. Almost all of my major resources can be reserved. They're giving that much confidence. Okay, that means you can really mine it. That means you can realize value of the major resources. Be very, 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 very careful there. So, because that when you say reserve, we are taking the taking this portion of this reserve and making decisions on the capital in the capital expenditure. That means a lot of money we're talking about spending there to make the mining happen. Now, who does the classification? Who makes the decisions in here? Is by the CP, by competent persons. We'll know, we'll discuss also, competent person may mean one person. It may be a team of experts in here, team of subject matter experts in here. Okay, so what really that means that, these people have enough qualifications and they have enough experiences, and again, they have to justify that, that they can make a skill judgment by the CPs. That means they're making such judgments that affects what kind of classification or assigning, and they have to justify that in writing. Examples of factors and parameters, cutoff grades is very well known. Something that we do not discuss actually, sometimes it's intentional, sometimes we see that people did not realize it. Deleterious materials. I know some of you are in the coal industry. If you are in the coal industry, you become these sulfides and mercury and high sulfur type of thing. They become deleterious materials, right? And you need to be very, very careful there. I see, as you know, more deleterious materials means is not economic. It's not, you cannot justify the mining. So that means, we need to say explicitly, okay, for so-and-so reason, for so-and-so minerals existence, we cannot declare so-and-so portion of the deposit as resources. And the level of accuracy of the resource estimation. The reason I put this third point here, what I have seen in my career, many times people make decisions on the levels of accuracy of their grade estimation. Resource classification or the confidence assigned by CP is based on the whole thing. That means quality of the data, the rigor that was used to justify the geological interpretation. And like I said in the beginning, is your the geological interpretation and your data style, EDA, exploratory data analysis. There are iterative processes. So is resource classification. Many times I've gone back saying, hey, this portion of the deposit, we have very less amount of data. And if we have the data, we don't have the pots for this drill holes is many different reasons. I have to downgrade the resource in that portion of the deposit from indicated to inferred, for an example. And that is real. It's not just looking at we have the kriging variance, we have kriging efficiency, we have distance from the blocks. Those are mathematical way of assigning preliminary classification. They just guide you to the final classification. They are not everything. I will emphasize on that. When you call the reserve, we talked about resources now. Reserve is the economically mineable part. That's why I stress a lot when you say the indicated and measured resources, because part of the resource will become either probable or proven. In some jurisdictions we use proven, sometimes which are proved deposits. They're very high confidence material in your deposit. That means if you mine it, you are making money, right? If the mine is operating by borrowing money from a bank is waiting for their return. So when they use their technical people, they say, well, do we really have this reserve? Make sure that you understand this is mineral reserve is economically mineable part of the resources. Okay, and like I said in the beginning, you need a PFS or feasibility level study to justify that using any Crisco family of code like JERC, SAMREC, or POR, or the Indonesia recently. Indonesia is also I forgot what the name of that code they have. Where you have that kind of jurisdiction, that kind of reporting, you have to have that level of studies to declare the reserve. Now, what are the modifying factors? This is just not the whole list of things that we consider. This is just some of them, or the more, major I'm trying to capture in this slide. Mining operations, process, metallurgical losses, economic factors, marketing, legal. It can be land. It can be legal, like, if you have a dispute on your land, and if you have, if you think it positively, okay, we have a dispute-free land. It's not just mining operation. Do you have a dispute-free land for your tailings and waste material? To give a real example, in Canada, we have an operation for titanium, and other materials. Pretty good mine, very high grade stuff in there. It's just that it's by a lake, surrounded by lakes. So when they put the material or the waste material, that waste material leaches nickel. That can cause, and there's a potential to leach some sort of material that can be dangerous for the fishes and the, all other animals that live in that lakes. So for that reason, that's an environmental and legal type of very messy situation. It's not the deposit doesn't have the material; they have everything. It's just the land they require to put their waste material. What we did there, actually, we did change the mine planning in a way that they have to mine certain small small portion of a small kind of deposits, satellite deposits there, and basically make the land available for the waste dumps. Otherwise, they cannot have reserve. They cannot have reserve. They cannot even mine it. So that's a practical problem. When you say probable reserve, I think I discussed that already. Part of the indicated resource and measured resource can become probable reserve. Now, when you say proved reserve, only part of the measured resources can become a proved reserve. You cannot take any part of the indicated resource in the proved. Remember, when you're saying the proved reserve.
No disturbance, please, gentlemen. Don't come in between till the session is over.
Now, when you say the proven reserve or proved reserve, you are really telling the shareholders here, we are so certain in our deposit that this portion of my deposit will give you the return on investment. You are really sending this message, okay? Just be careful when you say proven reserve there, okay? That sends a message to the market. Very important points in here. In some cases, proven reserve may not be achievable. That is just a fact. An indicated resource cannot be part of proven reserve. That is just fact. Reserve estimates are not precise calculations. These are estimates, not calculations. Two different words in here. Estimates and calculations. These are not precise calculations. So there will be some fluctuation when you go to real mining. Reserves and resources cannot be combined and stated together as a single estimate amount of material. If I were you, after this portion of whatever the material that I covered, I think this is the kind of the most important slide. Just make sure that you take these points that you cannot combine resource and reserve. When you stating reserve, make sure that you clearly say what really reserve means. So when you state the resources, make sure that you mention that whether that resource includes reserve or not. Most of the jurisdictions they will not allow you today. If you have reserve and if you have resource and reserve, there should be
Who is coming
separately
in between?
calculated.
Gentlemen, please refrain from disturbing till the session is over. I'll request all the participants to please stay on mute, not to come in between.
So I understand that in India we're still using a resource classification or the reporting criteria prescribed by the government that is very much linked to the UNFC classification. Remember the UNFC classification, I think that is 1999 version of that. It's a classification framework. It's not a reporting framework. It's not. And Crisco, why actually we're talking about the Crisco family of codes like JORC or MEAI 4311 or PORC or SAMET type of codes, they are reporting standards. Now, UNFC classification is a resource classification framework and public reporting, but the and JORC and other codes, they are for reporting standards, okay? So this UNFC framework is really good for management of resources, right? But these codes like EMIC or JORC or other codes that are used for reporting and raising funds from the stock exchanges. Many times, I would say more than 50% of the times, private investors who are not listed in the stock exchange, they also require a report complying to JORC or MEAI 4311 or depending on the jurisdiction of these investors. For an example, Bank X is actually in Indonesia funding a project in India. They will require you to write a report that complies with one of these codes. Because Indonesia is a part of Crisco, India is a part of the Crisco, and Australia is a part of Crisco. That institution may require you. It's not that you have an option. They will say, no, we will not fund your project unless you classify the resource and you report it based on this type of course. Again, it's this kind of a refresher for all of you. I think you all know this thing. This UNFC system doesn't require a competent person. So wherever there's UNFC system, they're trying to use it. The government has to step in and say, okay, define what is a competent person. You all know what's going on in India. It's a good tool for managing restaurant mineral inventory. It's a fantastic tool actually, to plan ahead by the governments. But when it comes to raising funds and setting up a project, this classification system doesn't work really. It's not a public reporting system, and no stock exchange in the world that I know that are accepting UNFC scheme. Just to clarify on that point, there is most recently, like weeks ago, in Northern Africa, they're trying to develop a code. I'm somewhat linked there because I was part of World Bank to go to help Nigeria. I'm not part of the team, but we converse at what really that's gonna look like. They're trying to use NFC classification and trying to develop a CP system, computer person system. I underline the word trying. They're trying. Okay, it's not a reality yet. Just Google it, you'll find it. I refer to these systems in here. Sorry, I didn't remember the Indonesian. It's called KCMI. It's the reporting code or the organization code. Most recently, Philippines joined it last year. Their organization code is PMRCC. Even United States had a new code. It's called SK 1300. It's a kind of sounds very weird here, but that's the regulation's name. Like in Canada, the CIM is the organization that manages the best practices, but the code name is NI 4311. That means National Instrument, and 4311 is the regulation number. So these there are 15 different codes. Okay, and they all use the same 6 different terminology that we discussed so far in the resource and reserve and also exploration results. It is an integrated system. You take any code, you take EMIC in India, it's an integrated system. You have to have a CP, and for CP, there's a system there, those kind of things. If you look at this thing, why it is so much appreciated and acted by the stock exchanges, really this slide is not really to show you the history of it, but this slide is actually showing you the history. It started in 1989. Today in 2023, Philippines joined, India joined in 2019. And 2020, actually, we celebrated in Washington, D.C. here in the United States. And all different codes are there, but what I really wanted to highlight here, this is a dynamic type of system. On the lower side, you see this color letter. So how many times every code has been revised. Once you have a bunch of countries revise it, then Crisco comes and basically have that template. Crisco publishes a template. Crisco doesn't publish a code. Countries take the templates and produce their own codes. Okay, now this is dynamic system that keeps all the member countries using similar terminology. What really that does, that improves the possibility of investment coming to the country. For an example, today Philippines, because they are member, I know Philippines is way advanced. It was very advanced, even before 2023, because their government was aligned with the organization, and they can accept investment from Indian companies if they use EMIC, and EMIC would be a code that Philippines really understands, because they're part of the family. The terminology is well understood. Australians can invest in Philippines. Peruvians, Chileans can invest in Philippines too, because they're talking the same language. That's the beauty of that. Now, I'm going to skip this one because we already discussed that portion. This is another slide. I think, to me, it's important for the participants. If you look at the Crisco family of codes in here, that's 7 different ways I see that, they're kind of different. One of the points I would like to make here is the number 4 one. These codes, such as NI 4311 in Canada, these set minimum standards for public reporting. That means when an investor looks at your resource reserve statements and the report, they say, well, we have at least this report meets the minimum criteria. Okay, and UNFC classification scheme just says, you report what you like. There's no like you have to do, and there's no set standards there. Okay, they give you these boxes. I think 40 some boxes there. You just put it, because there's no CP system there. You just put whatever you like, type of thing. So that then another point in this one is the 7th point. That is actually also the banks like it, investors like it, and stock exchanges really love that. So when I say, it's a NI 4311 report, it's a job report. I hope that in India, sometimes in the future, we'll see that EMIC is accepted by stock exchanges in India. They say, when you see this EMIC-based report, that means there's nothing called discovered uneconomic. There's nothing called undiscovered things are reported in here, because shareholders see, okay, fine. So our investment is not at risk. Okay, so that kind of differences are there. User reporting system is in public report, Whereas the system for public reporting, what that means is that public here means anyone can actually invest in your property. Now that includes direct investment from another country, right? That also includes public in your own country. They can have the report available freely and make their own judgments whether they participate in the investment process or not. This is just gives a totally democratic freedom there. Okay, by making these reports available in the through the stock exchange in public domain. This is another why the reports are liked by the stock exchange. There are three pillars in this public reporting system. One is transparency. You have to provide sufficient information and clearly present it. What sufficient means that when a reader reads a report, at that time, we are saying that we have enough information that we can make an educated decision in here. We can make a decision whether to invest or not, right? Sufficient information. You just cannot hide anything and clearly presented, not doubtful. It has to be clearly presented. And materiality, that means only relevant information should be presented. One of the examples I give people, like, let's say a company has 7 different deposits and they're trying to raise funds on a particular deposit to reopen a mine. Yeah, they have another 2 deposits. They're really producing good gold and stuff, and they're doing that. But that's not relevant to this property. That's not. Your company is doing well. That's different. But when the company raises fund to reopen this mine, we want to see only relevant deposits for that mine. For an example, for the waste dumps, do you have enough land to make this mine operational? Actually, last month I visited a site. They showed us the entire leach pad. I had to ask, like, is this leach pad, have all the material from this deposit or another deposit? And beauty was that they had they were actually tracking material going to the leach pad every week twice. That is very granular, very detailed information. That gives me confidence. Okay, they know how much material going to leach pad from this deposit, and they can mix up the other deposits because they have a land issue. But clearly saying that, people love it, as long as you transparently, and disclosing that, and only relevant information should be presented. Then the third point is all about CP. So the CP's qualification is tied to the type of information and the amount of information, and the way you present it is tied there. As suitably qualified and experienced persons, so it can be a team, they are qualified to make that kind of reports. So a CP system is what I'm trying to highlight here. Now, who is a competent person? I borrowed this slide and modified it from a past year of Crisco. So, well, you have to have a good qualification. That means you have a major, you have a basic degree, and often a geology or mining engineer active in extraction industry. And this is a scenario we were seeing this after COVID coming to us again and again. To us, I mean, to the industry. There's some people left the industry for 5 years. They're doing, selling insurance, doing whatever they're doing. Another guy I saw, he was doing greenhouse for 3-4 years, didn't do any mining. You just cannot claim that you have you include those years in your experience. Please don't. That's very unethical to do that. And becomes a member of a recognized professional organization in India. Is MEAI is a recognized organization. In the United States, there are 3 organizations you can be part of either of them. Yeah, in Australia there are 2 of them, AGI and OSIMM. in Canada, you have to you have to be a member of one of the territorial organization. And also you need to be part of, territorial organization. They don't accept the CI membership. No, you cannot be part of that. So you have to see where this reporting is happening. What is the RPO? I highlight the word relevant experience because this team of people or the CP have to have the experience in that is relevant to reporting either exploration results or resource reserve. For an example, I am not qualified to sign up on a report on reserve. I cannot. I don't have that. And my licenses are like this. The competent person is accountable for the reporting. Okay. Is there accountability there? Oh, one last thing in here. For all those people who are attending this course, and that includes me, we have to ask ourselves, the work that is going to my report, can I justify it? For example, if there's an audit, can I stand by my work? That is, I think, the most important question one has to ask himself to see whether he's a CP or not. And that is actually project to project. What relevant experience means, here's some examples. A CP signing off on exploration results should have training and experience in that area. A CP signing off on a mine planning and reserve estimation is expected to have education, training, and experience in those areas. I've seen only 2 people in my whole career who are not mining engineers, but they signed off on the reserve. But they took enough number of courses beyond their formal education to justify that they are CPs. And I have met both of them, and I have to ask them how they justify their qualifications. And not by I mean my team and our team. The geologist, for another example, a geologist with significant experience in ore control may not have sufficient experience in exploration and resource estimation, and cannot actually be a CP in that in a reporting scenario. Is because, see, what happens actually, you'll meet a lot of people who have been actually spending 20 years, 15 years type of time in a single project. That's a great thing, great example. It's just that that gentleman may not be qualified to sign up on another deposit. If that deposit, subject deposit, is different geologically than compared to the ones this person is working on. Like I put myself as a subject always because that's easy for me to do, to disclose who is actually who you are working for, what are your qualifications, and what are your contact information if someone wants to reach out to you. Remember, all the RPOs, and this is another beauty of the critical system, they're required, is not option, they're required to disclose the names of these CPs freely available to the public. Bedari sir, how much time I have?
It's now 6. You have 15 more minutes.
Okay, good then. I'm good. So again, like I said before, that the competent person takes the responsibility. It's good to be a competent person, but it's not a locket you can wear on your neck, or it's not something just decorative. It is a competent person. This is a third slide. I would say, take it and please read it again. It prepares the reports. Reports means it's not just a technical report. It can be announcements like public announcements, statements issued by the issuing companies, and it provides information to the exploration results. All of that I call it reports, or what is known as reports. It exercises judgment in providing external information. This is a very, 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 very important point when you are working on a brownfield or greenfield exploration. because that project may not have the best information, particularly when you have a scoping level scoping study or scoping level study. That means you don't have all the information, but you are trying to get into resource. Okay, not reserve, resource. Now, for example, you don't know, you didn't have time, or for whatever reason, you didn't know the recovery factor. How are you going to assume it? It's an assumption that has to be justified in the future. But right now, you don't. It's the exercising judgment is a responsibility of CP. Okay. And if you are practicing as a CP, you know, people come back and say, hey, so and so person, you signed up on this report. Please justify. How do you use it? Okay. And audits are real, reviews are real, and they do come and ask you the questions. It upholds the responsibility of transparency, materiality, and competency. All three of them is not either or. All three of them enables a balanced and reasoned investment decision. That becomes like this fourth point is the reason why all previous 3 points exist. Based on a CP's report, someone is making a decision on investment. It is a burden on your shoulder. It's not just a decorative thing. You take the responsibility there. A CP decision on resource classification, here's an example. We're dealing with a gold project. I think I mentioned, refer to this project. If what you're seeing here, this is a gold old mine. 10 years ago, it was operational. It was making money. What we see here today, when we visit there, there's nothing existing. The equipment that we see here, they don't exist anymore. Okay, but the query exists. The point was, okay, we see this mineralization. Here is a completely, we can take the sample today and basically see that that's mineralized even 10 years after. Actually, this pit, if you see today, the pit actually where my arrow shows up to that point is a kind of is submerged lake there. That's another economic issue, whether we have reserve or not. We're going back to the same pit, think, is this water, extraction of this water from the pit, is it doable? Is it economic? There's a lot of things, even at a county, what we call in India, we call district level and panchayat level in India. The similar jurisdictions in North America, we're saying those regulations, what they have, applying those regulations within their limits, can we extract the water? You just cannot tap this water and flow it to the river. You just cannot do it. Because of that, we are not able to declare reserve. But the question became, okay, it is the old mine. We know it was producing. There's all evidence there. We don't have a recent drilling. What do we do? How we classify the resource today? Because it was 10 years ago active. I made a decision to look at the pit because it's visible. I can see it. There are some drill holes. I can see the intercept there in the pit. I say, okay, what about I go 2 benches below, let's say in this diagram, the existing pit cell is yellow that you are seeing on this left side. The pit cell that you put there to justify how much material in today's context, today's criteria, if you apply to this criteria, that can become potentially mineable. I made a decision. I said, you know what? I can see this bench. So I make a decision in addition to the digital data that we have. Physically, when I visit as CP, I make a decision that all the material that I can see, I have enough confidence to call it indicator. I'm not assigning any confidence as much, like a major resource. I said, I'm not gonna do it. There are certain other things. So I said, okay, all the benches that I see, and I go another bench down below. You can see these blue line boxes there. I call them all indicator resources. I'm fine. And we're reviewing that classification again, and I'm saying, this is fine. We're still gonna go back there. That was a real example. Just to kind of last few slides here. to give an example of all the CPs acting in different countries, I have added the PMRC Philippines toward the end. These are 15 different countries in the part of the Crisco family. The designations may mean, in India, we call RCP here. Most of the countries, they call CPs. It's weird that in the United States, we call it, United States, we call it CP. But interesting is in Canada, we call QP. So I have to check what I'm writing in two different jurisdictions. We're in north and south of here, right? And Brazil said, we call it RQP, Registered Qualified Professional. And Brazil joined Crisco in 2015, right? So, what the takeaway from this slide is, doesn't matter what the designation is, their responsibility is the same. But another highlight here, Brazil and the United States, they are one of the strictest countries in terms of strictness, like how you imply and how you use your codes. To become CP, they require a position with responsibility of certain years. And some other countries, I'm hearing that they are trying to bring that also. That, let me clarify, that position of responsibility has nothing to do with your designation, like your principal advisor, senior geologist, or general manager, doesn't matter. What really that means, that person who is trying to become a CP can make independent decisions. That's what it means. You have responsibility to actually handle that. And you have to prove it, actually. You have to prove it. Try to become a CP in the United States using SME's RM, register member. You will see, they will call you actually, your referees and ask them. I'm not joking. They do call them and to verify whether he worked as a part of the team, or can the person make independent decisions. A CP system means it's a group of people under a company, large company like Tata's and Vedanta's in India. Here actually you can see the big company like Newmont and Barrick, Rio Tinto, all that. They have a CP system. What really that means? You have a multidisciplinary team of people, okay? They all are qualified to become a CP depending on the project. We dealt with a diamond project in Diapic in northern Canada. It's wonderful. At least you Google that project and see where it is. In that project, the geotechnical engineer and hydrogeologist, they had equal importance as me as a geologist, making decisions on the resource. Because without them, that project really cannot exist or cannot operate smoothly. I think that's all I have with that, sir. Do I have some time to take questions?
Thank you, Dr. Bani. Thank you very much for the nice presentations. You have described sources, resources, and finally the difference between CP, QP, and QCP. It was a wonderful presentation indeed, and I am sure the participants have enjoyed it. The floor is now open, gentlemen. If you have any questions to ask Dr. Bani, participants. I don't find anything in chat box also. Anyway, gentlemen, please feel free to ask if you have any questions. Okay, if there are no questions, gentlemen, may I request all the participants to please put on your video so that we can have a quick shot with
There's
Dr.
a
Bani?
hand raised, I
Yeah.
think, Mr.
Yeah,
Pradeep.
please ask. Please. Identify yourself and then ask. Tell your name, company's name, then ask the question, please.
Please unmute. Maybe it's not a question with that, sir.
Okay, gentlemen, if there are no questions, please put on a video. Let's take a quick shot with Dr. Abani. All of you, please switch on the videos. All participants, videos on, please. Good. Few more are left out. Okay, gentlemen, thank you. And we'll now meet next week when we'll have on Saturday again another wonderful presentation. It will be on the 30th. And before that, no, I'm sorry, it will be on 24th. 23rd and 24th, we have very good presentations. 23rd, it will be by Dr. Suryanshu and followed by MTC 25, which will be taken by Mr. Vijay Singh on the nine-bench judgment and its discussion by the Supreme Court. So don't miss that. I have already shared that link with all on Gmail itself, on group mail. I have done that. So thank you very much, Dr. Avani, once again
Thank
for
you.
the wonderful presentation you have made. And may I request Mr. T.R. Shekhar to please propose a vote of thanks. Shekhar Dab. Shekhar, you are there? Okay, Dr. Vani, thank you very much for the wonderful presentation that you have made. And if there are any questions, any queries later, I will forward them to you.
Thanks. Have a very good evening there. Thank you.
Thanks very much again. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay, gentlemen, then thank you and goodbye. We'll meet again next week and have the MPDP as well as the MTS both. It will be on the 23rd. Thanks and good night. Oh.